Adesso vado su, quando ho finito di cose vado su YouTube.
C'era uno spettatore che era entrato e è riuscito subito, però. Ok, live su YouTube, perfetto. Mi collego di là allora.
Vado a cambiare le impostazioni del video live.
Poi l'ho fatto l'upload dei sottotitoli giusti, eh.
Ok. Senti incorporamento, messo.
Sì, infatti mi dice ancora accensione YouTube.
Chat dal vivo, tolta. Ok, should be good to go.
Not yet. Continua a dirmi accensione YouTube. Sì, ma non ci sono spettatori.
Sì, sì, accensione YouTube, giusto? Cioè in alto qua, in alto qui sul coso c'è sempre scritto accensione YouTube.
Ma infatti non lo vedo però nel canale tra i live, non lo vedo. Ah, ok, adesso sì.
Secondo me non si affacciano nemmeno i due che devono fare tutto. No?
It's not that easy. I was trying to show my 3D in a cool HTML. Turned out was not that easy. It didn't work so well. So I tried browsing around for an answer. Took so long till I found this orange website where I heard singing this song. WEB3D is the place to be. Here your scene will not freeze, it will show like a breeze. You'll see WEB3D, you can join for free. Thanks Chronos and Ivy, and you can log in and then leave. WEB3D is in Italy. amare, the best of mangiare virtually. Don't be mad, don't cry and be sad. You will follow our rants, dress code underpants. Now picture that at WEB3D. It's so fun to be. And the social event takes you a tower that's spent. You see WEB3D is in Italy. I hope you enjoy. Good luck and then fun virtually.
Hi, Don. We're promoting you to panelist.
Hello, how's
Hi
it
there.
going? You've got our
Okay.
video, right?
Video.
You have the video okay?
Oh, where should it be? I have the Liu Feng video, but from 2D to 3D. She sent it this morning, but I don't believe it's for the session. Okay. No, have you sent it? I mean, you sent it in the Dropbox folder that we gave out. Where has been sent?
Anita said that she sent it. We recorded it from Web3D Consortium Zoom. I will call Anita. Hey Siri, call Anita Havela. So.
Hi, Dan.
Yeah, good morning, Anita. So Marco, I just talked to Anita. She's going to join the call. We recorded on 21 October.
Search. October. Yes, but she sent it through how? So she sent an email on 21st of October. So how did she send the video? Because I
Sorry, I don't know how she sent it.
okay, maybe I send a message.
I'm not available. I have.
So no joy, huh?
Cannot find any email or a link, and also the other guys, Fabio and the other Marco, are looking, but at the moment we cannot find a link.
Okay,
or
well, I do have the presentation here. Do you want me to present or do you want me to mail you the PowerPoint?
That's up to you if you want to. Okay, Anita said
What do you
she
think will be
sent,
better quality?
she sent the, okay. I now have the link, just bear it for a second. I can now download it.
Yeah, she just sent a mail.
Yep. Should not take this much. Okay, should be already here. Let me check if the video. Yep, it should be this one.
Yeah, there we go.
Yes, it is this one.
They can maintain.
Okay. So just a second. for spectators. So just a second, I will close some of my windows and officially start the session.
All right, Dick's here too. Morning, Dick.
Hi, Don. How are you?
Okay, thanks. That was me calling you.
Oh, I didn't get a call.
So, Dick, I thought of one thing we didn't cover, or maybe we did, but we might want to say a little bit more about projective texture mapping.
I think it's on our.
Give Kwan Hee you
slides.
credit.
Okay.
Sure.
Did we put that on the slide set?
We can start the session. So welcome. Welcome to the first afternoon session of this day. The first session is a tutorial, and just give me a second because I just lost my way. This one. Okay, let's start again from the beginning. So welcome everyone to this afternoon session. We'll start with the tutorial. The tutorial is X3D Graphics International Standard, Design Consideration and Version 4 Update. We have a video, and then we will have question and answer with the authors of this tutorial. So welcome, and I'll start the video for you.
Okay, hello. We're here to give a presentation on X3D graphics. My name is Don Brutzman.
And I'm Dick Puck. And we're happy to have
And
you
we're
with us.
gonna, yeah, very much. Okay, we should have a screen coming across. Is that the
Yes.
case?
Yes.
Great. So as you can all see on the title, we're going to talk about X3D graphics. It is an international standard. We are working on, of all things, version 4 after all these many years. So we're going to give you an update and where's the spec at. And we're also going to point out a whole bunch of resources and capabilities that are out there. Dick Puck and I have been working with X3D for many years and happy to be working together with them as specification editor with the X3D working group and with ISO. Okay, so let's keep going here. So we have a summary of all the things in this talk, and it's quite dense. There's a lot of information here. That's because X3D is pretty big. It's a big vocabulary, but it's also coherent, and we've mapped it in many, many different directions. File formats, we've preserved classic Vermal, we've got XML, we've got JSON, we've got programming languages. We're gonna walk through all of that. We're gonna walk through tools, and we're gonna especially highlight some of the new features in X3D 4 that add to the richness we already have.
It's important to note that throughout all of this enhancement, we have been very careful to avoid breaking backwards compatibility. So your old program should still work fine.
All right. So here's a short list of topics that we're going to cover. And it's really two parts. First is all the spec geeky stuff. And then second half is an inventory of resources. Lots of cool stuff. So you can pretty much jump in wherever you want and work on things, utilize X3D for as best makes sense for you. Okay, so here's our first part. The WEB3D Consortium. What is WEB3D? Well, when we first did VRML way back in 1997, we said, gee, we want to protect this international standard so that nobody can break it, nobody can take it, nobody can make it go away. So we incorporated a nonprofit that is been recognized as a standards development organization, formerly by ISO, and we have a very special relationship. We're in charge of all the spec development and making it all work, and then they're in charge of all of the formalization of documents and the rigor that make it useful for everybody. So it's quite a balance, quite an effective balance. Dick, can you tell us a little more about ISO and how that business goes?
Yeah, the standards development of X3D and the other WEB3D standards is through ISO, a joint technical committee of ISO and IEC. ISO is the International Standards Organization, and IEC is International Electrotechnical Committee, which is mostly hardware standards. We have been working on this since 1997, although computer graphic standards have been developed since about 1980. Of view of the WEB3D consortium, the primary standards, sets of standards are VRML, HANIM, and X3D. And each of those are multi-part standards. So each part having a designated role in the standards adoption process. And
the original VRML is VRML 1. VRML 97 had 2 iterations, VRML 2.0, and then there was a revision to it. And then when we went to X3D, it became 3.0, which then led to 3.1 and 3.2, 3.3, and now we're on 4.0. See, you can manage to achieve backwards compatibility all the way by being cautious, by thinking of X3D4 is a major upgrade to X3D. It has not broken it. How do we integrate well with web pages? How do we utilize and other advanced lighting techniques from Kronos in the GLTF, and also advanced audio and a few other things. A structure that we can make sure all voices are heard, all priorities are balanced, everything keeps going slowly, surely. What do you think, Dick? Is it working?
I think it's working. People might be interested in knowing the reason why we changed the name from VRML to X3D. That was because in order to enhance future growth, we came up with splitting the representation of the scene from the definition of the elements of the scene. So we call the definition of the elements the abstract specification, and that's what X3D Part 1 is all about. And then we have the ability to go to the ISO/IEC 19776, which is all the encodings. So far, we've got 3 standard encodings, and we're planning on standardizing at least 3 more. But each of these exactly represents the scene in the same way, so you can map between them. Similarly, we have a scene access interface that allows you to, from a separate program, interact with the scene, add things, remove things, change things, and that's called the scene access interface. And we have language bindings to the scene access interface, so that from whatever language you're programming in, you can call programs in that language to make changes to the scene.
Cheers, and it's definitely a team sport. Lots of working groups, lots of feedback from the public, and a real insistence on implement and evaluate before anything gets stabilized. So here's some key references for all this stuff. We don't expect anybody to memorize everything on the, boy, it takes a while. But we do want to let you know, oh, there's a lot of good things here. And you might find most interesting is our tutorial last year. And in fact, there's a lot of tutorials. 2020 was our 25th anniversary. We're now on our second 25 years. It's been quite a journey, and the Web3D conference is not solely X3D and verbal. It's a lot of other good things too, but it's been a real foundation for what we're up to. So you can go check out all this stuff last year, this year, hopefully next year too. Dick, you were just talking about the different branches of the specification. Here they are again.
Yeah, note that by splitting them apart this way, it means that each of the different standards has the ability to progress or change on its own. And typically the Part 1 of 1975, which is the X3 architecture, the abstract specification and definition of the scene graph, and then the X3D scene access interface allows you to interact with programming languages. We started off with JavaScript and Java, and are in the process of adding 3 versions of the C, C++, and C# programming languages, as well as Python. The 19774 is a completely independent standard called humanoid animation, which allows you to represent in a standardized way articulated figures, which may or may not be humans. They could be any kind of weird alien character that you want, but it's designed to handle any level of articulation. The X3D architecture has the X3D standard.
And that last point is perhaps the most important. The architecture describes all the functionality. That's where we say, here's how it works. And all these other things are variations on that consistent theme. How do we make it look the same everywhere? So that's a big statement. Boy, here's kind of our City of London subway map. How do all these things fit together? And you can see right here in the middle, there's that architecture. That's the document we're primarily talking about today. How does it work? And then we have, what are the different ways to say it? Is as a file, we have X3D XML or classic vermal, which looks just like the regular vermal except the version number at the top, and all these other encodings, JSON, compressed, etc. Then we have programming languages. How do we say the exact same scene graph in this language, in that language, and the other? So X3D Anywhere is definitely part of it. And then as you go outside the center of the diagram, we show the corresponding references. What are the other standards that we're aligning with so that our X3D core, our common architecture, is the same and rigorous and correct for all these other ways of doing business? There's about 83 other things on this particular graphic, Dick. Is there anything else you want to point out or mention?
We should point out that the things that are surrounded by dashed lines are things in process, while the things with solid lines are things that have been published.
And if you ever want to go to a detailed meeting, boy, you should see when we figure out what's a solid, dashed, different lines. There's our legend there. There's our key. And it's been gratifying to see. Well, we don't get a lot of strokes, but turning a dotted line into a solid line is a good day. Because it means we got a lot of work done. Okay, so this is kind of your reference card for how do these all fit together. The fact remains, it's the architecture that's the center of gravity for everything. Okay, so what's new? What's new? Well, this is the biggest. I think almost anybody in graphics would vote for this as the most important thing. We've maintained a fairly old rendering model, but we've now aligned with GLTF, which is Chronos' very advanced GL transmission format for 3D models. And so we are matching all the render capabilities and all of the lighting capabilities and other goodnesses so that X3D models can load GLTF, or they can convert from GLTF, or they can maintain older versions and new polygons, old polygons can coexist side by side. We haven't thrown anything out. What's your favorite part about this relationship? It's pretty deep.
We're fine. If they're metal, they should look like metal. They're plastic. They can supports all the things required by GLTF, and there really isn't anything in GLTF currently in the version 2.0 version of GLTF that we can't represent in X3D.
You want it GLTF? Great. You want X3D? Great. You want both? Great. It's use the right tool for the right purpose. Use the right file format in the right context. And our goal is is our executive director. She's been instrumental, along with a few others, to get this ongoing relationship solid so that the tech can align and the business models of different organizations can be fully respected without any short circuiting. App you saw, we're able to auto-generate program language bindings, and we did this by creating a machine-readable version of what the architecture document says. The architecture document is all HTML. It's an ISO standard. So we captured that in a way that can be used to produce code that exactly matches it. So we get validation, we get consistency, we get second implementations in multiple directions that can help us stay all this on. Well, there are some links here. There's some more description later in the talk, but we're adding all these things. We're excited that C, C++, C# are on the brink of active improvement now. We have an initial implementation and documents from our partners in Korea, and we're keen to keep building out on that. Okay, next is we've mentioned Kronos and GLTF. We should also let's see, I think I have to turn off my laser beam here. If it lets me. Okay, now I can actually click on a link. HTML authoring guidelines. We did not come up with something strict, but rather guidelines for how X3D can coexist inside the formal standards for HTML and for CSS. And in many cases, it sort of looks like SVG, how that fits too. So there's many considerations. This diagram is perhaps most illustrative. If we have HTML and it's drawing pages, and we have X3D and it's drawing 3D seeds, well, you can put it in, you can intersperse the HTML and the X3D, and everybody plays well with each other. 3D is a much faster cycle update rate, user interaction rate, but HTML has one too. So we've described how that works. We have not legislated one way to do it, but rather say, here are the outcomes, here are the results, here are the behaviors and the displays that a user can expect. This keeps the door open for implementations. There are several already to do it their way. This lets X3D browsers and HTML browsers continue to evolve, and our spec won't go out of date because it describes the end result. Dick, what I just said might apply to many other things about X3D, that we're functionally oriented. What's your opinion about this approach?
Well, it's an approach that I think is quite common, but it is not a requirement. It is perfectly possible to implement X3D browsers outside of an HTML environment as separate applications. And we have several examples of that seem to be used more in an industrial sense of whoever the authors are and whatever environment they're working in. But HTML is a very important one, and it's especially important for people.
Insistence on a consistent user experience rather than one way to write your code has stood the test of time. and it shows that the spec remains relevant even as software and web development matures. We've got another major piece here, and that's web audio. Web audio is interesting because it's now standard. It was many years in percolation. It's widely implemented in web browsers, and it's an API. It's a JavaScript API. And it could be JavaScript sitting on top of other code, as the abstract says here. And it has lots and lots of things in it, but it's all JavaScript. Oh, X3D is, you can do X3D in JavaScript, but you can do it in many other ways too. So what we did, and thanks to the team in Greece, Effie Laka, Athanasios Malamos, implementing and defining this, we are able to do audio in an X3D way so that we can model it as part of a scene graph, take full advantage of that functionality and integrate it in 3-space as makes sense for the models that you're building. So pretty cool, pretty cool. I definitely commend that work to you. There's papers last year, this year, a tutorial on its way as well. Projective texture mapping is also a really serious capability. It's interesting. It's sort of halfway in between viewpoints and textures from a technical perspective, or excuse me, textures on geometry that we're all used to, and lights. You could think of it as a texture-based light that you could shine around in the scene and get that texture draping over whatever it happens to point to.
Think of taking a slide projector.
Korea has been a key contributor here. Dick, please.
Yeah, think of projective texture mapping as the equivalent of putting a slide in a slide projector and then aiming the slide projector at your model or parts of your model. And this allows you it's a light source, and yet it's also a texture. Go back to the earliest one, Don.
Sure thing.
There. As you can see, we're shining a slide projector at the corner of this, say, a room, and it behaves differently on each of the surfaces. But the texture still applies, and that could be any texture. It could be a photograph, could be anything. And so what this texture does is allow you to spray images on arbitrary things.
And those images could be 2D textures or pixel-based numeric definitions or movies. And so powerful new technique. It'll be very interesting to see people start to extend and improve that. We've done a lot of little things here and there to make scanning, 3D scanning and point clouds better supported. And must thank the CAD Design, Printing, and Scanning Working Group for figuring out what were the little addition things that we need to really have a good workflow from beginning to end. We'll see some of those results at the end of this talk. We've also matched X3D support for the humanoid animation specification, which is been around a long time, got fixed and improved 2 years ago. That's an updated ISO standard, and what's great about this standard, this update, is it's not only very solid in all of its definitions of what a humanoid is and how do we define it, but we've added motion animation that's patterned after BVH format and quite capable. We've shown how to do it in more than one way in the standard, the H-ADAM standard, and then we've shown how to align it directly with X3D in the X3D architecture.
Yeah,
Dick, that's
well,
been a long journey. What are the most prominent lessons learned in your opinion?
the H-anim standard emphasizes the ability to accurately represent humans and human characters. It has been carefully designed so that any other articulated figure can be represented. For instance, it's easy to represent things like an octopus or an alien animal with 6 legs or whatever, and but it still does it in a standard way. And they should, all of those different representations should be possible.
That's right, and we've doubled down on that by saying, well, let's do humans really well. And I got to give a shout out first to Joe Williams. A lot of diligent effort. We now believe we have a fully complete, anatomically correct human skeleton with corresponding skin bindings. And looking ahead, our colleagues in Korea have shown that these exact same design patterns can be used for internal organs and possibly facial expressions too. So it's interesting when we move out of proprietary code bases and different ways of doing things and say, oh, we could have an open standard that's not only general for humans or animated characters, but it's rigorous enough that it might someday go all the way to human medical records and be a way to record people's physiology, people's diagnostics, changes, and just your personal health. So we expect to see more good, solid work building out on H-anim. Okay, let's keep driving on here. So from an ISO workload, work path progress, we are, let's get my laser beam again. We are here on the, we just submitted a CD, which appears to be functionally complete. It's now gone to national bodies for review. And we're working through, Dick and I, with the backstop of the X3D working group. We're making sure all of the phrasing is unambiguous, that software builders can read the spec and go, oh, okay, I know what to do. That modelers can read the spec and go, I know what to expect. And so, gee, Dick, it sort of feels like we've come full circle to the purpose of WEB3D consortium. Let working groups and the public to do fast technical work, and then the longer timelines of ISO can proceed in parallel while everybody has great confidence that it's going to go forward. Is that ringing true for you? Am I just doing happy talk here, or what do you think?
I think it's we should put a shout out to Roy Walmsley, who for a few years did a very, very rigorous review of the pros in the standard, and also the various connectivity portions of the fields, and making the field use of fields and nodes consistent. He's no longer participating, but a lot of the editorial comments we're currently looking at are a direct result of his very careful review. Being he's from the UK, so he understands English very well.
Yeah, we miss you, buddy. Roy's direct experience with the Coin 3D library meant there were few secrets that he couldn't get to the heart of, and we're still benefiting from his insight. Okay, and it is what it is. We're going to keep working on 4.0 and sort it out. Can people work on 4.1? Things like mixed augmented reality, VR, AR, XR, other things. Sure, go get them. Have a great day. But we're gonna make sure this 4.0 is rock solid across the board, across all these variations, and that's functionally stable now. So the ongoing good work, often driven by implementation and evaluation, can continue.
We should be able to finish the 4.0 development and have a published ISO standard in early 2022, because I'm still old-fashioned. But once that is done, the next thing is to get all of the encodings and language bindings caught up with the 4.0 abstract specification. And that will require a lot of auto generation. So the object model will be critical in quickly developing all of those different standards.
Hear, hear. And everybody will see that all this stuff is proceeding in parallel, and there's no blockers to these other things occurring now. I don't know if it's a bottleneck or just the gauntlet we always have to run is make sure that document can stand the test of time forever and ever, that everybody's comments and good ideas and, hey, wait a minute, all get reconciled. And Dick and I continue to spend a number of hours each week just to make sure that's going on. Okay, so now we're going to have a lot. That's the big picture. We're going to give you a lot of snapshots on things. C, C++, C Sharp. They're all pretty similar. They have the same DNA, but different. Here's the status report. There's been great work by Dr. Myung-Won Lee and her students and her colleagues, and we hope to capitalize on all her success with other things to regularize that. So that thing's in motion, and stay tuned or get involved, please. What do you say, Dick?
I agree. Should be noted that the scene access interface has two different methods for accessing the scene. One is through internal scripts that are part of the scene, and the other are access from external programs. In the case of C, C++, and C Sharp, these are going to only provide external access. But since the application development is very commonly uses C and C++ and C Sharp, this will allow them to more easily interact with the scene and make whatever changes the application being developed wants to do.
Very good. And at the end of the day, it's still X3D.
Yep.
So next, H&M. We've got a number of examples online. I think we have maybe 80 forum role examples. They've all been tested and validated. So this past year has been a lot of tool confirmation, tool improvement to make sure this is all working. And there's a couple of pointers there to future work. We're seeing some other synergies with the semantic web work. We were working on aliases. Frankly, I don't know how the doctors talk to each other, because we have not been able to find a single reference for all medical nomenclature. But there's a lot of common practice, and there's variations all over, just in English, much less other languages. We think we have the major aliases captured, but we can get out of the alias business because semantic web techniques give you a much better way of drawing those correlations, including across programming languages. Okay, next is ISO document status. And so the Web3D Consortium, because we carefully protect the intellectual property rights going in here, we accept all comments in the public, but the working group Web3D members get to decide what goes in or not. And we do not accept something if there hasn't been confirmed by somebody who says there are no known patents affecting this. And this goes all the way back to 1998 when we first established Web3D Consortium. So the bashing is all public. The issue tracking is in Mantis with members. The actual documents are in GitHub, but they're private access to members only. And then when they reach a high state of maturity, they go public as the X3D4 architecture is today. Okay, let's step forward. Mantis then is our issue tracker, and you've got just a scoop here, a snapshot. Dick and I keep pounding through editorial issues. We think we've got the hardest ones done that might affect ambiguous functionality, but we continue to plow through them, and I share Dick's at least optimism, if not optimism, at least hope that we finish this year. But we've been surprised before. Some of these things take a lot of careful thinking, phrasing, and comparison.
True.
Okay, so I should say that this is all there. Any member, whether you're a company member or a university or an individual, you can get full access to everything here and make your voice heard, make your feature properly, fully defined.
And non-members have the ability to add comments to the Mantis bug tracker. And if they are submitted as X3D bugs, we are very careful to review each and every one of them.
Amen. So that's the first half of the slide set. Here's the second half. Lots of resources on parade. So let's start. This is the first page to go to if you want to see what's the latest and greatest. It's web3d.org/x3d4. And there's a long history in here. We've done it for years and years, including when the X3D4 was, my gosh, 4 years ago at the Web3D conference. We've had annual updates, and what looked like maybe insurmountable then is all yielded and is coming to fruition now, including this slide set, which is the first entry on here. Okay, and then here's the specification itself. We linked to that before. I'll click on it right now just so you can see, yep, it's there. I can turn off my laser beam. Boom, presto. There it is. So you can navigate your way in and you can see what is the latest, greatest in the opinion of the Web3D Consortium and the opinion of the X3D Working Group, informed by the public on the X3D public list. Lot of stuff, and Dick and I don't stay up late at night inventing things, rather quite the opposite. It's a cumulative effort since 1997 achieving a large and formidable body of capability. Okay, now let's march through some of the browsers, some of the players for X3D. There are several that are just utterly great and really keeping track of what's going on. We wanted to recognize Michalis Cambarellis and his immense efforts with GLTF, getting it all to work. He also has a converter. He's also fully immersed in all of the details of both encodings and how they might work. You can barely shake a stick at all of the examples and results that he has online. So open source, it's supported by users. It happens to be in Object Pascal as his main language, but he's got full board GLTF and hardcore libraries underneath. Many features first come to light through his code base and his tool sets. Next most popular, or very popular, I shouldn't say next most popular, but the next one, which is also very popular, is X3DUM. And this emerged out of the Fraunhofer experts, and there are tons of people working on that. It's all, again, open source. It's out there. It has great support, great uptake. Still got a few gaps. We still are encouraging people to build some things, but absolutely a workhorse for many folks. So if you want to put X3D in a web page, you can use X3DUM for that. And we have, well, 4,000 examples roughly online that show exactly that. And then we have Excite, which is the other major JavaScript browser. And in fact, I believe that Excite is still probably got the greatest support of any of the players. We haven't done an inventory too recently, but they're up in the 90-something% of full capabilities, and no doubt working on some of the X3D4 things. Tremendous. Here's about 20% of all of the Excite examples that are just on the Excite set and website. And Holger Selig does amazing work and stellar rendering, as you can surmise from just some of these postage stamps. Closely related is he has an authoring tool that shares a lot of the same code with Excite and is used for on Linux. I'm afraid I wish it was on more operating systems. Maybe someday. We just got a Linux system finally dedicated in the lab. Hope to start banging on this pretty soon. He's got some really magnificent tools as part of this authoring environment, and quite dramatically effective as a authoring tool. Free World, honorable mention, a lot of good things going on there too. Again, open source, this time C++. So it's an application browser, but these are, most of the words you see on here come from the source, come from the originator. What do they say? So please check it out. They were one of our first hardcore checkers that all of the GLTF mapping could coexist well with the existing X3D render model. Okay, and then we have the mother of all laundry lists. It's just grown and grown over the years. When there's something interesting about X3D, we put it in here, and tools, resources to help authoring, books, conformance testing, conversion, examples, details on examples. These are all in version controlled examples. Import, export, And nature of open source. How do we go mobile? Searching for models. This is pretty interesting. I foresee that we'll probably be getting into the business of 3D search metadata in the coming years. Links to our different programming libraries that are out there. Quality assurance. How do we ensure that models are correct? Oh, and by the way, when they're correct in one form, then that tends to make them correct in the other form too. And as you might imagine, that's quite a big job, and it's all mutually beneficial. Every time we fix a bug someplace, we raise the bar elsewhere. We can digitally sign and encrypt X3D models in the XML form using other existing standards. So that kind of encryption is available today. And we've learned that if you want to compress too, well, it's a good idea to compress before you encrypt, or you won't be able to compress. All those details are here, including known security vulnerabilities. Curiously, if you read the fine print here, you see it's a really short list of just the X3D design prevents security vulnerabilities. But when we see somebody supporting ways to check, when we see flaws or hazards, we document them and share them, et cetera, et cetera, et cetera. Okay, so those are the resources. If your resource is missing there, tell us. Post it on the public list. We'll add it. Scene authoring hint. This is where we've collected one by one over the years all the different ways to take care of X3D. And because it's a big standard, because it has lots of interesting design patterns, because it's the web, because it ties to various multimedia, there are a lot of lessons learned and gotchas and good practice that you can take advantage of. So if you're asking, how do I do this? And you're getting beyond the tutorial stage, scene authoring hints can help you. Okay, and oops, been there, done that. Tooltips. Tooltips, boy, well, we have a spec. You don't need tooltips. If you want to read the functionality, just go there. But we have found over the years that there are lessons learned. And it's helpful to have this kind of short form. So for every node and for every attribute, for every field in the spec, we have tooltips and hints. A lot of it is redundant because we have consistent internal design in X3D. So, you know, if you learn about def and use, identification of nodes and reuse, well, you know how it works for all the nodes. But if it's an X3D4 new capability, then you see it in yellow here, and it's so identified. If it's something that was always there, well, okay, it's just in green. If we have authoring gotchas, hints or warnings, we toss those in. Okay, so painstakingly constructed. I want to get back to the index. I click on the little X3D, and if I want to see what it is, well, the very first link here always takes you right back to the spec and the index and then the spec itself. So the specification is authoritative. If there's ever daylight or gaps between the two, then we fix the tooltips. Interestingly, these tooltips, since they're structured data, we can use them in a lot of these APIs. So once again, cumulative mutual benefit. Okay, conversions, these are sections in the resources. There's lots. By lots, I think, I don't know, we're up to 3 dozen in this one and another 15 or 20 in the other. And those are just the ones we've been keeping track of. Many ways to convert because X3D is an interchange format. Our goal is archival use, reuse. Blender will be one of our biggest challenges in the current year. Not challenge so much, technically not a challenge, it's just opportunity with X3D4. How do we mainstream that in the stellar capabilities of Blender and the new features of X3D? It should all work. Plenty of times for people to get involved. X3D Validator, this is one of the NPS things. Let's take Hello World and validate that and see what happens. You can select a file on your local system, or you can put in a URL, and somewhere a server is crunching, and more than a few links here of how it all works. And what it's doing is it's going through about 9 different tools that have different ways of testing an X3D model. And so here's our result. Let's see what it says about our Hello World model. Okay, it says it's 3.3. It's passing XML checks, docs type, headers, DTD validation, which is string-based, schema validation, which is data type-based. We have some additional checks when we convert back to Bermel 97. So basically, this is a backwards compatibility check. We have regexes, regular expressions that look for malformed floats. Those can be insidious errors in your model if you're unable to detect them. Schematron is a bunch of rule-based testing. Well, if I have this there, I shouldn't have that there, or make sure you add the other thing. Tidy is a cleanup. And then finally, the pretty print. How do we turn that plain old XML into linked and hinted HTML so you can get basically documentation for your model? Okay, so that's a validator. Very useful tool. Quality assurance means you avoid garbage in, garbage out.
If you have some trouble with something not working right, running it through the validator might point out exactly what's wrong.
That's right.
It will speed up your development.
And then sometimes the errors identified in the first part are answered or hinted in the second part in X3D Tidy and Schematron. They say, well, I want to do this instead of what you did. And if you're still stymied or stuck, please tell us, because every one of those rules was built one at a time. And if you found a hole or found a gotcha that's new, great. We want to give it to everybody else, and we'll integrate it. Okay, I'm happy to report that X3D Edit is climbing back on its feet after some downtime. We've got it. I built and ran it just this morning. We hope to update our auto installers in time for the conference. Active work. Here's an example of a material editor in there and what it looks like. We have XJ3D integrated in here to visualize things, yet another browser. XJ3D doesn't yet have a whole lot of support for X3D4, but it is open source. It's Java. It's pretty powerful, and we're certainly keen to keep that thing going. Okay, shameless plug corner is a book. We do have a book out there, X3D for web authors. Tons of slides, tons of video, tons of models. We have used this for a course here at NPS. That course is now online. So if you want to teach yourself X3D, and this matches the level of detail in the Vermeil source book, another great reference, you can use that. Okay, I mentioned examples. Well, here they are. You can count up. Okay, we just broke out. Yep, sure enough, 79 H&M examples online. 416 examples from that Vermal source book. That's in fact where we started with X3D, is converting all the source book examples into X3D. We pursued that further with the NIST conformance suite, which had an immense set of tests for Vermal. They're all upgraded and up there. Okay, so we're creeping up to 4,000 models here. Pretty interesting. And we keep logs of unit testing of all of our quality assurance for that. Okay, next reference is for validation. Where do you get those documents? If you're a tool builder, you want to use them. Well, it's all online. They're referenced in each scene, but here's where you get them. As with most of our work, it's version control. So when there's an improvement or a correction, there's definitely a trail and a history of how this all works. Here are the links to the unified object model. Again, this is a machine readable version of what the architecture says, and it's used to auto-generate the next things, such as Java. We have a full-up Java library. The Java slang for this is it's all plain old Java objects, POJO. So you can just use it with any other Java program. Similarly, Python, there's no dependencies on other libraries that might conflict with what people do. It's all, as far as we can make it go, best practice Python. And automatically generated and automatically installable in your local Python through PyPy, the Python interface library.
It's important to note that Python.
Okay, we've done.
Python is a language that was developed after X3D, and yet when we started developing a Python interface to X3D, it turned out to be relatively straightforward using any of the Python environments.
Correct. Thank you, Dick. Okay, we've done a lot of work on JSON. It's not formalized yet. We've been waiting on the JSON schema to get locked in over at Internet Engineering Task Force, but that's now appears to be at a pretty high level of maturity. John Carlson is Coder Extreme, is our main man there, and he's got an updated JSON schema that he is auto-generating using the Python package x3d.py. And so now we're going all the way around the world and back again because of this consistency. And we're soon to get into testing of the update to the JSON schema. Pretty interesting stuff. There's the links to John's work. His biggest contributions are the JavaScript library for X3D, all hand-coded. None of his stuff is auto-generated. It does leverage some auto-generated stuff, but he's got his work in open source version control, and you're welcome to check that out. Okay, other work documented in online is how do we get X3D into the semantic web so we can start doing queries and other things. Jakub Flatinsky and I are working together on that one, and it's yielding. It's by looking at patterns, design patterns, and best practices. We have auto-generated a ontology. It was reported out in great detail. You should be seeing a tutorial from us in this year's conference. And there's no doubt a few things I'm missing, but even with all that immense detail. But a shout out to the conference itself. ACM, SIGGRAPH is the primary sponsor. The conference site is now on web3d.siggraph.org. You got to point out the webpage now has not only 10,000 downloads of papers this month, 25 years of papers, but we're getting close to 250,000 downloads altogether. And that's since they started. I'm not even sure when their starting point was. Our publication point was 95. Wow. 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 This is all adding up. Here's a point of interest that happened in a meeting this week, so I tossed a slide in. Yes, indeed, X3D is a registered trademark, and at least in the United States, and you can look at that. So the WEB3D consortium is looking out for everybody's interest to make sure that X3D not only stays well-defined, functionally correct and complete, but stable. Okay, Dick, I think we're on the end game now. Some eye candy. Shall I put the video up?
Sure, go ahead.
Okay. Here was work by Versar, John Ouellette and his team, and also Virginia Tech, Nicholas Paulus and Peter Sforza. And they've been modeling the Naval Academy, U.S. Naval Academy in Annapolis, Maryland. And I have a confession to make, Dick. Every time I start seeing some of this stuff, I have this sudden urge to shine my shoes and show up. So, you know.
Just stand up and salute. That'll do.
Yeah. If I suddenly start marching, please take over. You know. But anyway, you can see this is immense scene, a lot of stuff. I think Nicholas described it the other day. They have at least 7 different sources of data that they've integrated. The trees are not exact tree scans of one day, but rather tree models that are put in the right places and size. A lot of different databases got pulled and modified to show these things. This is not a pretend location. This is a real location, and you're seeing firsthand some of the, not just the features, but the ability to take advantage of the web. These floating boxes over here, these are not drawn with X3D. These are drawn in HTML. In fact, you can look at the URL in this video we're watching right now. You see, oh, it's an HTML page that contains all these models and models holding other models and building a big place. And wow, that's pretty cool. This one was done, yeah, April 1st. No, really. And Nicholas was showing me an upgrade the other day. We were talking about it's getting so big, it can get bigger than even new machines. How do we take care of that? You just saw a second ago, well, here's the underwater portion of the scene. This was done by side scan sonar from an underwater vehicle and merged with a bathymetry database. And a lot of the land, the shoreline, and other things were done by air vehicles. The Army Corps of Engineers collected some significant data sets. He also walked around with handheld scanners and not yet in this model, but being integrated are tunnels, scans of tunnels. So here we go. Nicholas's compression discussion ended with, well, since X3D is web-based and its URL is an ordered list, you can put any version, the lower fidelity, the compressed, the higher fidelity, the super high fidelity on a list. And depending on what the author wants, and depending on what the user has access to, then the right resource gets chosen at runtime. Okay, and it's still going. Let's hide that bad boy, and you can see here on the right, that's Dr. Paulus. We grabbed a few of his screenshots. He's showing the same content in a cave, and he's walking around and striding over the campus and inspecting and clicking and exploring things. And improving the model yet further. Same X3D. So you can run on a desktop, you can run in a web browser, you can run in a cave, you could run in headset, same X3D. And just when you think we've said, go ahead, Dick.
You can also run it on your smartphone.
Thank you. Yeah, and I should probably call it up. If we go to the globe model, you're going to see that in WEB3D user experience tutorial. Yeah, you can query the globe for get your weather report on your smartphone as well, using X3D in that case. You could probably do it in Excite too. We'll prove that out. Okay, and if you just when you think we've overflowed and said everything, we realized right before the talk today that, we forgot to mention 3D printing. So here's a link to a project, again, happens to be NPS, but we took a vertical projector overhead and 3D printed some of the same models that exist in this 3D scene and started superimposing them and pushing toy boats around the table and looking at it. So if you want a detailed slide set of how we put that together, feel free to go there. 3D models can be rendered in all those different ways, but they can also be rendered physically, printed out. And
it should be
cool.
noted that a lot of the commercial 3D printing companies that provide a 3D printing service use X3D as the basis for their models.
Exactly right, including Cura 3D, open source software by Ultimaker, which is the #1 3D printing software. Native support for X3D. Can load it just fine. I think our unofficial slogan is, but wait, there's more. But not today. We appreciate your time. If you made it this far into the tutorial, we want to acknowledge that this is absolutely a team sport. We've just listed here the folks who've directly helped in recent years on the specification. There's a longer list back in some of the documentation. We're grateful. Everybody has benefited from everybody else. And as you've seen from just a few snippets here today of actual models, but the grand variety of things emerging in the conference, wow, 3D is moving out to the web. X3D4 is stable. It's available. People are putting effort into tools and models that illustrate it. Dick, what's your lead out statement? What's your get off the stage statement here about what does it all mean?
Well, one of the nice things about X3D is that if you have developed a model in X3D 3.0 and you want to take advantage of some newer feature, all you have to do is change the header statement and then add the requisite scene graph elements for the new feature, and everything works.
So backwards and forwards compatibility is part of the mix here. And how do we keep striding into the future without losing anything that's come behind?
Everybody should really enjoy their 3D.
Yep. Our contact information is on the last couple of slides. Again, we're grateful for your time. We're grateful for everybody who's working on this. We're grateful because it's fun to be part of and powerful. And gosh, what a shared public resource for everybody.
Thank you for attending.
So sorry, Dick, go ahead.
I was just going to thank everybody for attending, and If you have any questions, with our email addresses are on the contact page.
Outstanding. Okay. Thank you.
Bye-bye.
Bye. Okay, well, here we are. Let the bouquets and the tomatoes begin. We're very happy to present and Dick, I know you want to as well. Thank everybody for the immense efforts that brought us all here
Absolutely.
today.
If you have any questions, please raise your hand using the raise hand icon, and we'll try to answer them.
Well, just a comment. I mean, the amount of information about the standard is impressive. It's one of the few standard and format that are well documented and are really accessible on that side. I mean, it's not often, especially for web technologies, that sometimes you have to go through endless pages and endless question and answer and Stack Overflow to know all the detail. In this case, you have a lot of information online and a lot of pages of documentation. That's clearly an advantage for anyone that want to exploit this technology.
It's great to hear you think that, and thank you. We work hard on that, and it makes us slower, but there is something slower than doing good work, and that's redoing good work. So we try to get it right the first time, and we try to put it out publicly. And I got to say, that's more than just a service. That is part of the due diligence, part of the scrutiny, part of everybody going, hey, does this really work? Does it make sense? Can I use it? And I think that is a hallmark of our community, that we're open to share. We try to say not just what, but why. And every year I walk away amazed by what we see here at this conference. So again, thank you.
I'm curious about what you said about 3D printing. In most cases, to drive a 3D printer slicer, you just need geometry. So a lot of the other parts of the X3D format are kind of, I don't know, just get the geometry nodes and you.
I think part of the audio dropped out. I'm not sure I heard the question.
So is X3D why you should use X3D for 3D printing when you normally only need geometry to drive a slicer. I mean, the other part about everything else is just ignored except for the geometry. It's how does it work? What does it offer above STL?
Thanks. Well, Vince, would you like to take that one? Vince Marchetti is the lead of our design, printing, and scanning working group.
I'm curious, it was not a criticism because a lot of time when you work with printers, the file format, a lot of printing software is really picky about the file format, and they say, oh, you have a wrong things here, you have using an extension that I don't like, and so it's with such a large format. Vince,
well,
you should be able to,
mm-hmm.
Your microphone is open.
Yeah, thank you. And Vince, pile on if you get your video going. So it's a great question. And most 3D printing these days is going on with STL file format. And if you look closely at STL, well, it doesn't take too long because it's all geometry. It's just triangles. Mm-hmm. And it could be plain text triangles or it could be binary triangles. Now, don't get me wrong. I love triangles as much as everybody. A triangle is wonderful, but that's all it says. It doesn't say what color is it, what material is the object in real life, what materials might be useful for 3D printing, what was the origin of that model, who authored the model, what was the source and the provenance of changes to the model, what's the functionality of the model, where can you learn more about the model, what are some example screenshots of the model, what are some viewpoints that tell you what the model does, what is interaction, and the list goes on and on. And so do you need all of that to print it? Well, maybe not. Do you need all of that to make sense of it? Probably if it's a serious model. And we pondered this for a long time because there's excellent support for X3D and 3D printing. Cura is by Ultimaker. It's an open source printing program that's immensely professional. It's a #1 tool and it has direct X3D support. So we pondered this for a long time, and it almost seemed like whatever angle we started from in 3D, plain old just WEB3D, whatever, somehow we would circle back and come to 3D printing. So I have a slogan that only took me a year or two to come up with, but it kind of captures that. So here we go. I'll type this in a minute too. 3D graphics turns bits into information. 3D scanning turns objects back into bits. 3D printing makes it a physical object. Did I leave anything out? Anything in reality, anything in our imagination? Wow, we're coming full circle here. And so I personally suspect, as much as we're doing these days, everybody's doing with 3D printing, we're maybe just on the cusp of understanding the true power of what might be possible. Vince, you with us?
Are you muted, Vince?
See his mouth moving.
How about now? My microphone.
Okay.
Okay, my microphone battery, because I was silent for so long, which is unusual. No, I think Don pointed out, first of all, immediately X3D does provide multicolor support. And I'm most familiar with the Shapeways service, that that is the way if you wish to submit a multicolored printing job to Shapeways, X3D is the preferred format. Now, understanding that there are kind of, I would call them ad hoc sort of STL extensions, which support different colors, and those are exactly what they are, ad hoc, and X3D has the spec and the standardization, the material properties are baked into X3D, not added on as an afterthought. So that's an immediate, is the multiple color support. Going forward, and this is the typical problem where you think about things you can do with X3D, and then it's a problem of getting our authoring software and our consuming software to cooperate. So Don mentioned adding information, we call it metadata, which can include things like provenance of the file, who owns it, who copyrights it, who has permission to print it, as well as suggestions for how to print it. And, for example, one thing which is important in 3D printing is the orientation. How do you place or how do you build up? If it's one of the machines that works in layers, what's the preferred direction of the layers? And that could be specified as metadata information. There you have the problem is, then you have to get the 3D printer software to extend its capabilities to use that. And I think having a well-designed specification hopefully is an encouragement for people to write software, to a known standard. And the second feature of X3D is we have built in the idea of multiple parts, or even within our CAD capabilities, assemblies. So, an STL file is just basically one blob. Now, it can be a blob with two disconnected meshes, but there's nothing in STL which says, you can identify this is the left side of your assembly and this is the right side of your assembly. Only print the left side, something like that. But again, in X3D, that capability is built in. So that's my answer, and we're happy to extend the discussion.
Well, don't get me wrong. I don't like STL particularly. I know it's a pretty basic format. It's super long and has a lot of problems. I know perfectly. Now I understand better the kind of work you are doing. So it kind of extend also to different printing materials. So you can, with machine, with multiple, using multiple material at the same time. Yeah, I get it perfectly now. It was just sketched in the presentation, so I wanted to know more about it. Yeah, so thank you.
Vince, you've got your hand up. Do you still have a question? The answer is no.
So are there other questions from the audience? I think William Glasgow posted something on the chat. User interface for a semantic query of a scene graph. If I query the scene graph for things or properties of things, what is rendered and what returned?
Don, you want to take that?
Yeah, William, you want to describe that? I'll give it a crack. I think I know where you're going. We're gonna see in the user experience tutorial that
I have to give him the permission to speak because it's just I was just a spectator. So
I see. Okay, very good.
You should be able to speak now.
William, you're on.
I see his microphone is on, but not receiving any.
He's got his hand up.
Yep. And the microphone is now on.
William, you can talk. Make sure your local muting is turned off. Because we cannot hear you.
Okay, well, I'll give it a crack. So William asked, will you talk to user experience for semantic query of the scene graph? If I query the scene graph for things or for properties of things, what is rendered and what is returned? Okay, so thank you, William, for shaking a stick at the future, and there's a lot there. We will have a tutorial on user experience, a group tutorial that describes the progress that's been made in going, not just in how do we work with 3D navigation and interaction, how do we work with integration of information on the web page and the rest of the web, but the future goal of a user experience cycle, of a feedback loop where you're defining goals, you have metrics for user success, you're taking data and you can tell if you're getting better or worse, and so all the serious work on the web is doing that. We are trying to figure out what are the best ways for 3D to be part of that life cycle. Okay, so that's the first pass. Second pass on your question, with semantic web, we're finding that, well, the metadata is so important, but the structure of the scene graph is also queryable. That's what the X3D ontology allows us to do, take advantage of semantic web capabilities. And if you read Sir Tim Berners-Lee biography, Weaving the Web, you see that the semantic aspects of the web were part of his initial conception, his initial design. If you read what semantic web says today, it says how to make all data accessible on the web. That's a pretty big stick wave. So if we go, well, let's see, if X3D has a lot of converters, if X3D has a pretty common denominator scene graph, if we can map to and from STL, if we can map to and from GLTF, if we can map to and from other models, well, I think we're starting to perceive the horizon here, which is, could we do queries across any model, whether it's in X3D or some secondary or tertiary or other form that our tools are able to not just render for us, but maybe reach into and grab and look for the shape patterns, look for the geometry, look for the metadata, look for the search engine sidecars of what's in there. And so this is the bigger picture we're striving for. Is it boiling the ocean, as they say? Yeah. Yeah, it's everything. It's the web, and this is what happens when you get serious about the web. The key challenge is scalability. And then, William, you get the prize for a triple question. What is rendered or returned? There's a wonderful slogan by Jim Hendler and his authors in the semantic web that listen carefully, please. The answer to your question is the response to the query. The answer to your question is the response to the query. If you don't get a response to your query, maybe your question's not well formed. Maybe the answer's not out there. This is why search works. You type in stuff and there's enough information on the back end that it can I give you some answer, and if it's a well-formed question, you get a well-formed answer. It's all related. This is what we're striving for. User experience will be the loop at some point that tells us, is it working or not? I will now go rest.
Okay, there's a question
hand is
coming
still up,
from
William.
the
Do you have
WEB
any
question and answer that ask, how do you see applicability of X3D if it comes to high performance application, like hyper-realistic games or a scene that span whole countries or the globe? And question comes from Christophe Valentin. And
Yeah, you want to tackle that first, Dick, or what do you think?
Please do so. Go ahead, Don.
Well, I could tease it apart a little. Christophe, thanks. First, high performance. High performance is kind of in the eye of the beholder, and it's not constant. It changes over time as our capabilities change. But it's a very good question. Dick, what do you think?
I agree. I'm not sure how to answer the question since it really is in the eye of the beholder. And high performance applications such as real-time gaming, I think any particular development environment is capable of doing that, provided that the hardware resources are sufficient. There's nothing in the X3D spec that limits the ability to create real-time behaviors, and there have been games created that are based on X3D. So I guess my feeling is that it really has to do with the environment in which you're operating.
Yeah, and let me build on that. The gamers are nothing if not sincere and emphatic, but I gotta say the gamer definition of hyper-realistic tends to be a lot lower than the reality definition of realistic. And here's a trick question. Be careful if you use this with people. What's the world's biggest database? There are many fumbly answers. The only correct answer is the World Wide Web, because that's where all of the data goes. All of the data. Oh, and all of the engines and all of the physics models and all of the current status reports. So we can take a little sphere, a unit sphere that has one parameter radius. That's not very realistic. That's pretty simple, but it's mathematically perfect. Oh, and we can drape a globe on it. Oh, and we can touch any point on that sphere and do a query to the web and find out the current weather. Not yesterday's weather, not last year's average weather right now. So who's most realistic now? I don't view it as necessarily which one's better, which one's worse, but rather we have the biggest possible palette as authors, the biggest possible playing field and palette for creating things that anybody can use. So there's my take. Thank you, Christophe, for your work and for your question. I forgot the caveat. Your mileage may vary.
William has a backup question in the chat, Dan.
Okay, so William's question, if I query a humanoid animation scene graph, for how many times did the character kick her legs, will the query engine return a number? Okay, well, the answer to your question is a response to the query. Are you keeping track of how many times it kicks? If you have a loop in there, maybe a time sensor that loops for a given number of times, then we could query, well, what's the time sensor driving the orientation interpolators, driving the kicking motion? What's the length of that time sensor and what's the interval? We divide the overall duration by the kicking interval and we go, okay, 17 kicks. That's one way to answer that. Another way to answer that is something's keeping a ticker somewhere, perhaps a kicking score judge for the H&M Taekwondo video we saw a few hours ago. We go, oh, okay, 18 kicks. Or the answer is nothing. The answer to your question is the response to the query. So if you don't engineer it to be answerable, if you haven't thought through what is your user experience and how do we measure that and what does it mean, then okay, you got what you got and have a nice day. So design is super important. Thanks for the question, William.
Okay, do we have any other questions from the audience? Otherwise, we can have a break and then get back for the next tutorial at 5. So in more or less a quarter of an hour. It's okay for everyone? Remember that the question and answer on Hoover remains alive for the whole conference, and you can contact the authors of the tutorial and ask questions also later. So thanks everyone that participated in this tutorial. Thanks to the speaker, and well, pour yourself a coffee because conferences are for coffee. And see you at 5 for the next event. Thank you.
Thank you. Bye-bye.
Marco.
Yeah.
You could probably make announcements about.
I lost you. Announcement about. But then I lost the.
You're very faint, Anita.
Can you hear me now?
Yes.
I said, could you make announcements about the live competition? I don't know how many submissions you have during the sessions, maybe before or after some sessions.
The Flash showcase.
Yes.
On Friday. Yes, I sent to all the attendees an email and a Vuva message on how to submit. Already, I think 3 people submitted an idea for that session. So if you have created something and want to showcase it to the whole conference, please get in the Hoover community. There's a topic about signing up for that live session at the end of the conference, when you can share your screen and for 5 minutes show all the conference what you have created of interesting of 3D on the web. If you have problems, just reach us through email or through a message on Hoover, and we can help you in organizing it. Okay, see you at 5 for the next.
Bye, everybody.
Hello, this is Vince. I'm just testing my microphone. Is anybody hearing me?
Yes, I can hear you perfectly loud and clear.
Thank you. Thank you, Anita. I'll also, let's see, just test sharing the screen appropriately. Anita, are you still on? Or is there anyone still on listening?
Yes, I'm here.
I just wanted to run my recording just for a few seconds to make sure the volume is about right, or that, you know, all our setup is. So let me start. Did you hear it?
No, I can't hear the recording.
Okay.
Are you playing it now?
I just turned it off. Let me adjust my, let's see here. I'll try it again.
Hello, Vincent.
Yes? This is Vince. I was just testing my playback and I didn't know whether the playback was playing over the Zoom channel or not. Can anybody confirm or deny?
We couldn't hear the audio.
Okay, you did not hear it.
How about the others? I don't know.
Let me ask if there's someone who is, I guess, the host or the controller. Is there a setting you have to enable my computer audio to go over the Zoom channel?
Hey, Vince.
Yes.
Hey, Vince.
Yes, Don. Oh,
I think I did hear some audio from your video play. Might try it again with a higher source.
okay.
Volume.
Any luck there?
Nope.
No. Okay.
No.
We can just see your slide set, but no sound, no audio.
Okay.
So it says when you share screen, check and include sound option. Nicholas just
Okay.
sent.
Okay. Thank you, Nicola. Let me do that. Let's see. Share screen.
You'll just have to go live then if this doesn't work.
That's correct. Okay. Share screen. Okay, maybe I need to
And
unshare.
on the bottom left, yeah, stop the sharing, share again. On the
Okay.
bottom left, there's also share computer audio or something similar, depends on the interface.
Okay, I see share screen. Okay, I hit this, and this time I'll hit share sound. And maybe I should say optimize for video clip. The sharing part is only a portion, but let's try it again then. Oh,
Alternatively, we still have time. If you want to send us the video, we can broadcast the video on our site. It's up to you.
I mean, the video, okay.
Yeah, just upload it to the Dropbox.
Okay, it's about a gigabyte.
Just,
Okay, so I will first of all, let me see if this works now. First of all, am I sharing the screen? The one to nbviewer.org. So again, did you hear me that time? The My Binder isn't working during this tutorial. I invite you to open the second link, also available from the Hoover app. Did anybody hear my voice then?
yes, yes.
Okay. Okay,
It's very low.
But the connection is pretty choppy somehow. I was breaking up, but maybe just me, I don't know.
No, also on our site.
okay.
Marco, maybe you can just
Well,
send
we
in
have
the Dropbox link and just upload it there. Vince, we still have time.
I will start that. I will start that process of uploading. Let's see. The Dropbox link is all in the instructions, but if you have the Dropbox links handy, you may find it faster.
Yeah, just put it in the or email it.
I'm searching it.
Yes.
I think it's also in my email with some instructions that I sent out last week.
Just a moment, I cannot find the link.
Oh, I don't have it. Hold on.
And you know, the other thing, if the audio isn't working correctly, I can simply stop the audio portion and simply talk, as the video goes by.
Okay, it's in the chat.
All right.
Forgot, it was on the website.
Okay, I'm back. I had to silence my phones. Oh, and I will also do as suggested, silence my Skype or turn off my Skype. Just so I don't get called by an angry farmer.
So it's uploading.
Yes, it is. I do not think it will be finished in time, though. But if the audio is not coming through clearly, what I can do is I can show the video, and the video is not the entire video is limited in length. So, and then I can simply repeat the narration, repeat the talking part.
Okay, as you prefer. I mean,
Yeah.
it's up to you. We normally have like 5 minutes at the beginning of the session, so don't worry. We still
Yes.
let people come in and
Right.
Vince, we have time. I think broadcasting from your end is causing some network issues. So
Okay. Well, it is uploading, and we'll see how that goes. Yes. Or for that matter, I could simply not do the video at all and simply, because it is just me going to the Jupyter website, maybe that'd be the best solution at all. Okay, if we want to wait, that's fine with me. But as I say, the video still has 15 minutes, and I'm prepared to simply forego the pre-recording, simply do it live again. So
Yeah, okay. So yeah, if it's 15 minutes, yes, because then I have to download it here and then start
yes,
the broadcast. So it will be more than 15 minutes.
Right.
So yes, if you want to do it live, perfectly fine. And you just can, so now kill the upload because otherwise it's taking,
Yes.
also that thing can take your bandwidth, and
Yes.
it's probably better if we go live.
Okay.
And so welcome everyone to this new tutorial, which is collaborative 3D visualization using X3D, Python, and Jupyter notebooks. We are waiting for the final technical adjustment, and then you may start when ready.
Okay. Well, I believe I have ended the upload, so I think I've got all the bandwidth for this very important application. Welcome everybody. My name is Vince Marchetti. I'm a member of the WEB3D consortium, and happy to be delivering this talk today. First of all, let me confirm that I am sharing the correct screen. You see the title, Collaborative 3D Visualization? Yes, good. I'm going to delay a lot of introductory material, but I think it'd be fun or be, more exciting to jump right into showing you some 3D content. So I have a live example of a Jupyter notebook, and I invite anyone who's at a laptop to take this opportunity.
I think you are still showing the first frame of the video.
Okay, well, what I'm showing, let's see. You see my cursor?
I see your cursor. Yeah.
Okay, so actually my video started with this slide. It's all very meta, very otherworldly. Because I on my other screen, I'm actually looking at the notebook. So this is a PowerPoint slide. I put this up here for introduction and also to invite the participants to follow along in sort of real interactive time. So on this PowerPoint slide, and this is really helpful for you because you're viewing it over Zoom, but also in the Whova app, I've included 2 links. And in fact, just occurred to me, I should put these in the chat, which I will do. I hit the wrong thing. Oh, I'm not copying the link correctly. Copy link, right? How do we copy a link? That's how we copy a link. Okay, I've just finally figured out how to copy the links into the chat for the conference. So I invite And this is a bit of experimentation. I'm not aware of what's going to happen if 8 or 9 of you try to log into this simultaneously. I hope we can find out as an experiment. But I invite you to open the best one might be the one called Dynamic and Interactive. That's to the mybinder.org site. But if that doesn't work or you get tired of waiting, the lower link, the 1 to NB viewer, is a static, that is a non-interactive or an almost non-interactive version of the same notebook. So I like a cooking show where the meal is pre-cooked and just pull it out of the oven. I am going to make believe that I clicked on this link and my notebook showed up right away. So I jump to the view you're seeing and bring up my notebook. Okay, so now we're no longer seeing a PowerPoint. We're seeing this notebook. I know, let's see, do I see the hands? I'm looking to see if I can get some kind of feedback by raised hands or so on, whether people are having problems with loading it, or maybe one of the panelists who's trying can give me an idea.
And it works. It took a bit to come. Well, I don't know the exact term. It was showing a black window on top, doing some stuff, but I can see the notebook fine.
Well, that's great. So just for those of you who are seeing it, and it's in the video, and I'm sure the video will be available in afterwards. But those of you who did it, you might have seen, as was pointed out, the black screen. You might have seen a swirling thing. When you logged in, you were actually launching a virtual machine that had a certain amount of Python code loaded in, and it started this notebook. So let me explain, using my copy of it here, what we're seeing. The notebook is a series of cells from top to bottom. The cells which are shaded are Python code. And although I'll be talking about Python quite a bit, one of the themes I hope is that this notebook idea is a way for people who are experienced Python programmers, I would consider myself in that group, can collaborate with people who aren't experienced Python programmers, who aren't experienced programmers of any kind, or just don't want to do coding. So what I hope to show is that with the combination of the code and documentation and hints embedded in the notebook, we can allow, again, your collaborators who don't want to be coders to contribute, to modify the scene, and contribute to the program. I will go in more detail during the course of the tutorial what you're seeing here, but let me just quickly do a flyover. First of all, let me do the big reveal. What I'm going to do here is I'm going to clear the output, because sometimes we like, for the purpose of this, we'll clear all outputs. This is just to help illustrate. I'll go down what we see in the notebook. Again, we see the Python code in the shaded screen. We see documentation links, which you or I can modify if you find what I wrote unclear. There's a drawing or an image to help us see what's going on. And just quickly fly over. And a lot of nothing, because we actually haven't run this yet. So I'm going to show you, I'll scroll back to the top, sort of the most important instruction you can have in one of these notebooks, and that is to run everything. And that's under the run menu. To run all cells. We can talk in more detail. The Python notebook has a little bit of the flavor of a spreadsheet, in that you can change one cell, and if you run that cell and everything under it, which is a command, it sort of does the update correctly. But that can get a little bit complicated or at least get you out of synchronization. And this is a fairly simple notebook, fairly simple calculations. So let me dismiss whatever this was. Let me do the run all. And now I have to go back down to the bottom. Oh, it didn't run. Okay. Let me try to run all again. Still not there. Is an error? Okay, it's in that. Okay, so another important hint is for sometimes when things get clogged up, you have to do what's called a restart the kernel. And now we'll try run all again. Oh my, still not there. This is embarrassing. Okay, let me try this one. Ah. Hey, it worked. Okay. Okay, so this is the result of you know the work I've done, or at least running the cell, is we get this geometric figure. And I will explain in the next, when we're done with this quick introduction, what is the significance of this figure. One significance is that it's, again, fairly simple, but does illustrate the ability to use Python to do numeric computation and then show it in an create the X3D scene and then show it in the browser. It also has the advantage that I'm not using anyone else's data or code, so I can easily make this code open source and openly distributed for the for the purposes of the tutorial. I do use this notebook for some of my clients, and again, the issue there is that's kind of work for hire. So in my case, I'm not as free to distribute the code. So I've chosen to go with this example. And I will show you later why I'm choosing this, but let me just show off some of the capabilities now. First of all, as you said, or as I pointed out, what we're seeing here is a cone that is in blue, intersected by a plane. And if you remember some of your Greek geometry, the intersection of a plane with a cone is an ellipse, and I've drawn that ellipse in black around there. So far, that's sort of a one-hit wonder, and now we get to the point where you might want one of your collaborators might say, you know, oh, that looks fine. I want a different looking cone. I want either a wider cone or a narrower cone. And this is where, again, the notebook makes it possible for your collaborators to suggest that and even implement it. Unfortunately, we have to go up to find the place. And now it's a question of the quality of my documentation. And if you don't like it, we can fix it in real time. I know where it is. And I happen to know that this quantity called alpha degrees tells you how wide the cone is. And we said, well, 30, maybe one may think that 30 is too narrow a cone. I want to make it wider. So let me increase it to 45. And again, well, I'll just demonstrate. All I really should have to do is run from this cell downwards, or to the end. And that actually is one of our notebook commands, run selected cell all below. Right? Now, again, I see it. And I know perhaps you don't remember, but it has redrawn this figure with the cone wider. Again, similarly, someone could argue or claim that, well, this is good, but we want that plane to be at a little bit higher incline, and if that will make the ellipse more elliptical. So again, I run back up to my thing there. As the person who developed this, I call beta, and I give beta in degrees, the angle the intersecting plane makes with the horizontal. 15 is a little bit shallow. I am going to increase to 35, make it steeper. And again, run this and everything below. And now let me run down to my final figure. Well, okay, a couple of things have gone awry here. It is, it has bigger, but everything's gotten bigger. So I've got to make a few other adjustments because my plane is now doesn't really illustrate what I want to. Let me, since my video, I was able to adjust these things. Let me go back up just to, because I want to move on to the next interesting thing. For the same alpha, let me make my cone narrower this time, and that will let me get a wider angle. And if you're a Python, you may have if you're a programmer, you may have noted I have this kind of warning here. If someone does input a combination of alpha and beta that add up to more than 90, if you think about it or draw little pictures afterwards, you'll see that that means that the plane never intersects the cone the right way. So, but let me run this and we'll see the picture and we'll move on. I'll run all cells and come back down. And there I've redrawn it that way. Now I will have to say that this notebook is what's called the classic notebook, and that's the only kind of notebook I'm really familiar with, but there is an extension to this Jupyter called Jupyter Lab that my understanding is it would have enabled me to put this window up closer to that code that I was modifying so I could see it. I didn't have to scroll back and forth. That's it's probably a great user interface idea. It's just it's one that I haven't learned how to use yet. And you know, I'm sure that there are, or I suspect there are people on this who are, you know, also very experienced users of these notebooks. And I welcome any suggestions you have, either for this notebook or in general, that you can share with the rest of us. Now, if you excuse me, I'm looking to. Is there a way that I can see if anyone is raising their hand? I don't want to keep talking and miss hand raised questions. And I thought that as a panelist,
at the
I would
moment,
see.
no one. We can probably tell you if someone wants to.
Okay,
interrupt.
thank you. Okay, well then, this is my chance for audience interactivity. So, you know, if I were giving this a lecture, I would pose this to the class and ask for someone to speak up, but I'll just ask you to raise your hand. There's one thing you see in this visualization, and I'll bring it in, is sort of things in there. And that is just because you know, we're specifying using X3D a cone and a sphere, and I've done those calculations which are documented in that image I showed earlier, so that this larger sphere is sort of exactly inscribed inside the cone. But once you then in your computer graphics, you convert those into meshes and triangles and things, and then you plot them. Due to round off an error and those kind of things, the mesh for the sphere does seem to pop through the mesh for the cone in a few places. And visually it's kind of distracting. So this is my my question to the audience to see who's paying attention or who's engaged is, do I have any suggestions from my collaborators here today about what to do about, or is there a way to fix that, that visual glitch, if you will?
You just write on the chat if someone want to
Right, you write in the
answer.
chat, or if you want to raise your hand, or okay, William, that's a good idea. And actually that is possible. William Glasgow suggested increase the polygon count. And yes, I think that's a good idea, and it is possible. And we are using, the underlying rendering here is X3DOM, and there is a way to increase the polygon count. On the other hand, that's kind of it's a little bit of chasing your tail, because that increasing the polygon may not necessarily get rid of the artifacts, because you're still turning a sphere into kind of a pointy polyhedron, and you're turning the cone into a pointy polyhedron. And no matter how many faces you make, they're still kind of pointy, and it's possible that the sphere will still pop through. No, Don, that doesn't work. You can't just call it a feature, not a bug. We're developers, but we're not going to use that excuse now. Anything else? It's kind of a cheat, and when I say it, it might be obvious. William, use Boolean logic. We're trying to keep things simple. This is for people who aren't necessarily graphics professionals, and I'm sure that if you ask a 10-year-old, they would come up with this answer. Okay, you've all got it. Okay. This is a little bit of a cheat, but this is my answer. It's a visualization. We're not machining it. It's not a device that keeps poison gases from entering our atmosphere. My solution is make that atmosphere little, that works. Again, we have to count on the visualization being, the documentation being appropriate. And later on in the tutorial, I can show you how to change the documentation. Hopefully the way that I set up my varying, it's maybe obvious, or can always be better documented. But here I've said I'm creating a lower sphere. It is X3D based, so we're using a declarative style programming. I simply create a sphere, I put it in my scene graph, and it's going to be made. This lower radius is something that was calculated earlier, but I'm going to cheat, and I'm going to make it just a little bit smaller. So I'm going to multiply it by 0.99. So visually, you won't see that the sphere is no longer tangent, but it will collapse in. Again, I've changed that, and I do my run of selected cell all below. Now we're going to see if it worked. Bravo, it looks like it did. By making that sphere, again, to the careful observer, it still looks as tangent, and but you lose those visual, you lose those little glitches, and that's kind of the, we can't forget that when we're making these visualizations, there's always some element of art, and remember, art is the first syllable of the word artifice, which means you're allowed to fake things a little bit in the visualization. And I guess before well, this would have been the end of the pre-recorded part, but I'm doing it live. We can argue about my choice of color. So again, let's remember that I've drawn my plane as red. If I go up to the place where I'm creating things, here we go, the plane shape. And this does require a little bit of familiarity, at least with the terminology of the X3D standard. You can see that I'm defining a plane with some length, width. Beta just tells you how it's tilted, but the appearance, if you people with some experience in X3D might know that appearance has to do with how it appears, and I'm creating a material, and the material does have a certain color. We use this is not physically based rendering. So the 100 would correspond to red being 1 or 100% and the other two being 0. If I want to make it a green, I can change the red to 0, the green to 1, and again, run all and below. And now we come down, and lo and behold, it has turned to green. I do plan to return to this and go through in more detail, as conditions warrant, to what are the other parts in here. Oh, I should, before I leave, just so he doesn't forget, because I want to give an acknowledgement or make a connection with the previous session that I know some of you were on. If we go to the top of this notebook, I hope you all notice that one of the Python libraries that I'm importing is X3D. And I just want to, Don and Dick Puck mentioned it as part of our Python binding project. And it was mentioned that they prepared a Python package, which is distributed, and that x3d.py is a critical part of this notebook and other notebooks I'll show you later. Again, this notebook is really based on Python programming, and that x3d.py module is key to quickly preparing the X3D scene graph in the notebook. Again, if we want to, I can show you, because that X3D is kind of infrastructure, which we import from externally. This notebook does use kind of a custom task library called Common Geometry. And I will say, let me just show this feature, because it is important that we're collaborating with people. I explained that when you import Common Geometry, I explained that it's a Python package which uses X3D. We can include that documentation right in the notebook, or at least directly visible from the notebook. So bring this up, and it brings up documentation pertinent. So again, if one of your collaborators wants to see these mysterious functions, cone, sphere, and tilted plane, we get the documentation, which was automatically generated by a package called PyDoc. Let me return to my notebook. And I got that error message. Okay. I think we're still seeing nope, I got the one. It looks like I have lost my notebook again. I will restart. Okay, I've seen. Well, while I'm restarting it, let me again give a place for us to ask questions or raise your hand, and I will restart my notebook. I seem to have clicked things in the wrong order. Also, let me get some reaction where, again, I'm kind of curious how this whole format is working. Are the people who have the notebooks or are trying to run it, have you been able to make these kind of changes, or do you have any questions we want to talk about now? And I'm looking at the list of hands being raised. Let me run all again to make sure I do have my nice picture. Okay, I'm back to my nice picture. I should have pointed out, and this is again one of the things that is kind of important, is that in the things that I've done, and I don't know whether it's because we have so many people running this machine, but we do have the opportunity to save the changes that I made. If you remember, I'm back to my original picture from the notebook. Again, with the red plane, with these visual artifacts. If I had been paying attention or more careful, I did have the opportunity after making every one of those changes to save it. They called save notebook, and that actually downloads it to your local machine. As I go into this tutorial, I'm going to point out that it is also possible to run this Jupyter notebook completely on your own local machine, where you have a little more capability of saving things and using Git to save your changes. And that actually is how I develop a lot of this work. So this deployment on Binder is really to help people who don't have or don't want to have all the Python code on their machine. Before I leave this notebook for a moment and return to my PowerPoint, I just want to emphasize, this is an important point, is that those of you who are running it know that you didn't have to install anything. This works on any computer with a a modern web browser, assuming it opened, the Binder opened. You did not have to install Python or any of these libraries to use it. That's an important feature in collaborating, the ease of deployment. Let me put this to the side for a moment and return to my slide set. I like that I've done 40 minutes. I'm only still on the first slide. While we're here, I guess I can quickly open up this. I'll emphasize the difference between the dynamic and the notebook. I do have this other link called Notebook Viewer. Let me quickly open it. The Notebook Viewer is a much less complex environment. It's simple, but it does allow you to quickly in a sense, publish among your collaborators what you've done. So if you just want your collaborators to see any work you've done rather than necessarily letting them modify it, this Notebook Viewer just gives you the view at a certain point in time. So this would be a way of communicating your latest work to your team without them having to go to Binder. And I do have a slide later on discussing the how all these different websites are connected. But let me go to my PowerPoint. I also want to keep an eye on whether there's any chats or whether there's any hands up, and I don't see any. So I will press on. Okay. I told you this, I would say, why this figure? Because other than the reasons I said, is that it's fairly simple computationally, so everything is very responsive and fast, and it's open source, and so I don't have to worry about I can freely make all the code available. This is also kind of tempting, which which I found interesting for a long time. So I'll just give a real quick justification for why I'm doing it. First of all, as I said, that it's just you may remember, or you've heard somewhere that the intersection of a plane and a cone is an ellipse, and that's this, the black line, which marks out the intersection. If you ever, in sort of when you were very young, sort of elementary school age, read any books about astronomy, you heard about ellipses probably as the orbits that planets take around the sun, and all these sort of elementary astronomy books always say, they give us how you draw an ellipse. And this is a picture from a carpenter's YouTube, is you kind of put these nails into a piece of wood and a string, and you trace out the ellipse. And it always kind of interested me is, what is the connection between this idea of tracing out with this kind of string construction and the idea of the ellipse being the connection, the intersection of a plane and a circle, or a plane and a cone? What this is really saying is that every point on the ellipse, the sum of the distance from this nail to the pencil and this nail to the pencil, that sum is always constant. That's what it means to trace out an ellipse, because the loop of string is always the same length. And then I discovered a while ago the picture from a book that explains what's the connection. And I will not go through the actual, this segment is equal to that segment, and that segment is equal to that segment. I'll simply, point out that it's proven, and actually, it's actually kind of elementary if you follow the logic of this line equals that line, and that line is equal to that line, and they all add up the same way. So the goal of this notebook is eventually to explain this idea with a 3D visualization, and even add some animation. So as as you trace out this ellipse, you see how all the lines match up. That's just why I chose that. Another reason why I chose this figure, to illustrate the power of the notebook. Again, checking any chats or suggestions. Okay, now we kind of the overview, or the static part of the tutorial, kind of explaining what all these different sites and pages you've been looking at. If you go on and and I guess I meant to put this link on it, but actually if you do a search for Jupiter, and one advantage of misspelling Jupiter in the name of this project is it's very easy to find on the internet. So I invite you to, if you're interested, Google Jupiter, get the jupiter.org website, and there's more information than you'll ever need about Jupiter notebooks. The way I think of it and the way I use it is, a notebook is a task. So in this particular case, the task is to draw this geometric figure in visualization. In other work I do, a task might be to read a point cloud from taken by GPS measurements of a construction vehicle, to create a mesh from that point cloud and to plot it in 3D as an X3D visualization, and then maybe also color it using the height or some other property of the surface. That's a task, and you could write it as again, this is a standalone Python program or Python script, but by breaking up into this notebook form, I'm able to work with other people in my company, or who I work with, who are perhaps not as familiar or don't have the skill or the wish learn a lot of Python by breaking up some of the simpler things they would want to do and modify into easily understandable commands or those kind of entries we can change in the cells. I'm able to have a task such as prepare, cut, fill surface, and they're able to make some modification on their own to get the visualization the way they want it. So let me kind of, oops, I jumped to the end too fast. Am I really at the end? Okay. Again, let me check for chats and hands. I don't see any. The center of this particular collaborative project is, as many people, is a GitHub repository. So all these things are all the work that went into this notebook is available on GitHub. I have the link there, and perhaps in a minute we'll look at more detail as to what's in it. As I pointed out, I actually develop mostly on my own computer. Whoops. So I have a local Git repository, and I have a local environment that runs Jupyter on my machine, not in the context of an external server. Although maybe I didn't make it clear, Jupyter always runs in a web page. So when you do have a local Jupyter environment, you're actually running a little HTTP server on your computer, and your interaction is exactly the same way. You're interacting with a web page. It's just a web page being served from your local computer. And I've kind of given the hints. So what goes into installing this? Actually, the installation is not very, it's cross-platform. So at least in the world of Windows, Mac, or the common Linux distributions, the installation is pretty straightforward. And again, this Jupyter website, which I actually have given a link to the installation tutorial on that Jupyter website, it actually installs pretty straightforward. And I do my development on the local machine. Then you upload it to GitHub. And then there are these two other websites, which again, I know that I don't know the exact institutional relationship between all of these, but the Binder site allows you to, again, as you may have experienced, run a virtual machine that will, again, make your notebook available to others. And there's also this notebook viewer that just gives you a static view. It's a way of publishing your notebook. Both of these at load time or runtime do go back and query your repository, your own GitHub repository. So as your collaborators make changes or additions to the notebook, or all the things you can do with GitHub, such as fork and create branches and even roll back if you make mistakes, all those things can be deployed very rapidly and efficiently because it all has this common source in this repository. Let me, again, I'm asking about questions or comments. And again, I don't see questions or comments or raised hands yet. So I'm actually running toward the end of my prepared material with the intention where we have the freedom of going back and looking at whatever people had a particular question of. So if you have any suggestions of what you want to go back, in my original notebook, the ellipse and the cone, or if not, I will press on to my next thing. I didn't realize I switched out of showing the slides. I'm actually showing the PowerPoint, but that's okay. The example I had of the cones and the balls and the plane was really kind of simple. I was actually introduced to this as part of the work of the WEB3D consortium our design, printing, and scanning group is very interested in taking CAD designs, computer-aided design, and visualizing them in X3D. And one of our associates, Dr. Andreas Plesch, implemented this in the form of a notebook. So I am going to try to loading it in Binder and see if we get any kind of how rapidly we go. I'm going to open the hyperlink. Let me bring it in. I will say that one feature of this work by Andreas Plesch is that, and this is, it actually loads a quite elaborate runtime environment. These instructions you see about opening OCC or from OCC import. OCC stands for Open Cascade, which is quite a large and extensive CAD library that combines C++ code, again, a very large C++ library, and a Python interface that C++ library. That actually is quite a complicated thing to actually load onto your own computer. So this work that Andreas has, where all this stuff is done on a virtual machine, makes it easier. Now, the other side of this is that the virtual machine has to load quite a bit of stuff. Oh, here it comes. Okay, so now we're doing, and okay, so again, if we remember, what I have to do is I have to run all. Oh, run all. Okay, we're not getting there. So let me. Okay, oh, I'm sorry, I wasn't paying attention. I'm getting this note saying the kernel is starting. This is probably as a result of the kernel refers to the underlying Python library, and it has to load all that things with OCC. So let me wait for a limited time. Let me just see what no, okay, that's mine. Kernel starting, please wait. Well, while we're waiting for it, I'll come back to it again. I will go to the, see if I can use Andreas's notebook viewer. That is the static view of it. It should load quite a bit faster because we're not trying to actually create a virtual machine. Okay, so here you see the result. What this is, it's a mechanical assembly. This started out as a step file, and those who are not familiar with that step is these days is probably the international standard for exchanging computer-aided design and manufacturing information. So the achievement that Andreas and his associates did was to, again, within the context of this notebook, load a step file using the Open Cascade code, converted to X3D, and then rendered it. And we get a 3D, visualizable model. With the same opportunity, again, the Open Cascade has its own learning curve of how you would control it, but this gives us the possibility of you know, perhaps again, a collaborator who was completely familiar would be able to make some changes. In fact, let me just check the notebook and see if it has been able to start. Let me run all. And did it render it? Oh, okay. There's. Let me try run all again. Why are we getting number of shapes? List in, okay, I'm not going to try to in real time debug. I'm not sure what's going on here. Let me just check. Andreas, are you on this call? Because I think Andreas was going to be was going to attend. I don't see him. I'm not going to try to debug it in real time.
Yeah, I see him in the audience.
Make Andreas a host, and he can help me fix it in real time. That'll be Andreas Plesch.
Oh, no, I found another Andreas, so it was not this
Another
guy.
Andreas. Well, the other Andreas, do you know how to fix this?
No, I believe it was the wrong Andreas, but
The wrong Andreas. Okay. So let me go back, because I did want, and again, particularly because of our host, I wanted to go back to my slide here, the PowerPoint slide, because and one of the somebody wrote in the chat a similar thing, and actually, you know, quite honestly, I was not aware of this until very recently, like the last 24 hours, but it occurred to me. I mentioned that this Open Cascade, which is primarily for computer-aided design files, has a Python interface, and you know, I know there are many people here intimately involved with the MeshLab application, which I and other people in the X3D community have used both to manipulate and process our scanning files, and we're very appreciative that MeshLab well supports X3D. And I have to admit, I was not aware that MeshLab also has a Python interface called PY MeshLab. So another avenue or thing to do is to start creating some of these notebook tasks. Again, I think of them as tasks. You know, given scan data from a certain source, process it, analyze it, convert into a mesh, and generate X3D. This is certainly something, you know, we can take on in the future, is make these notebooks available. Make the mesh capabilities of MeshLab available in these notebooks. I'm gonna, since I am inviting okay, William Glasgow, I had a comment. Okay, William, that he's asking some very important questions about use of digital twins and so forth, and that's you know, I guess unfortunately I'm the wrong person to ask about business opportunities in the auto industry. I'd like to be more knowledgeable about it. You know, CAD is a critical part of obviously engineering and manufacturing automobiles these days, and you know, there is a lot of interest in using these visualizations now. There already are plenty of sites where you can configure your car, where you know, in sort of real time, you paint it different colors, or you add options, you know, different trim and so on. But at this point, you know, something like a standards-based solution, or even this, is more applicable to, I like you said, the sort of the repair and maintenance. And let me just say, this is the environment in which my clients work, or they tend to be small. Well, the acronym is small and medium, but I would think that most of my clients would count as small enterprises. Now, quite honestly, these are enterprises that cannot afford to pay 5-figure, and that's a US dollars, license fees per year to a particular CAD application. So these kind of solutions, which rely on, Python, which is essentially free, at least there's no licensing fees. And again, X3D, again, free as in very permissive licensing, and free as in at least no upfront cost. I think there's a lot of future in these small and medium enterprises for this kind of solution. Again, to keep down their software deployment cost, and also to get them out of the rat race of having to always upgrade to the latest version, which is another factor. But I have kind of come to the end of as in free puppy.
Okay. Well,
But I say
MeshLab,
I'm helped.
yeah.
I'm sorry. You had a comment about MeshLab? Yes.
Yeah, the PyMeshLab is a bit new, so yeah, it's something that came out recently, and we are working on that side because we always needed some way of scripting MeshLab, and now we are trying to do it through Python. And Paolo Cignoni, which is the main developer, has just written in the chat that they are doing experiment on Jupyter notebooks, and they were trying to figure out which was the best way to display the data as it was computed by MeshLab, and X3D is probably one good option to do so. So
yes,
you probably need to get in touch and work on that side to ensure the full compatibility.
Yes. Well, maybe this is an opportunity to go back and look at some of the code. Again, the power of this X3D Python package is that it expresses sort of what I would consider the large and mathematical part of a point cloud, which is a point cloud is a lot of coordinates of individual points. Python, along with the NumPy, which is a pretty standard numerical package for processing, and as I use in this notebook. That's a great way to handle large amounts of coordinates, and there is a direct conversion from the NumPy coordinates to put it into what we call a point set in X3D. That's kind of a one-line statement in Python. And I can go back and show you the notebook. Then there's again sort of it takes up 2 cells, but you can put it in 1 cell to take your X3D instance and convert it into the form that X3DOM wants, which is what we call the HTML encoding. So since we do have a little bit of time, I can go right back to that in our original notebook. Here it is. Just to give you an overview of how this works, I have created at this point a scene graph, and I call the figure the word figure. Jupyter Lab is complaining. I've appended all my parts, and the last thing I do is I append an ellipse, and this is sort of the entire rendering phase. I put a little bit of HTML. Stop complaining. I put a little bit of HTML, which sort of sets the dimensions as CSS style. Also this HTML actually loads the X3 DOM library. And then the next step is to a little bit of boilerplate HTML with an X3D node, which is sort of recognized by, maybe if I restart this, it will stop complaining. Well, it did stop complaining. And no, it didn't stop complaining. Okay, it's going to complain. But anyway, the point is this is the entire rendering part is, simply take the instance which we created with the X3D package, and just this SC stands for scene. It's an instance of the X3D scene node. The HTML5 just puts it out in HTML encoding, and it's sort of inserted into this HTML markup. There's a little script which, this window X3 DOM reload is just fires off a JavaScript to tell the X3 DOM library to essentially to do the rendering using WebGL. But as I say, that this notebook, most of the cells in this notebook are not devoted to preparing the rendering. They're devoted to do this calculation based on the different angles I set up. And right, and Paolo has pointed out that they're already using NumPy in PY Mesh Lab, and that's, I completely agree that NumPy is the way to deal with scan data, at least up to a very large thing. And I'm not sure why it's in. Maybe I should just reload it. And NumPy is really quite compatible with using our X3D library to change your list of coordinates into, well, in X3D, our point clouds are rendered with point set. And if you do the creating a mesh, we have X3D supports several different mesh types. Your index triangles, face sets. So that's how that works. Again, if there's any suggestions or more things you want to see, maybe it'd be best if I simply, again, reloaded this notebook. And it will make it a little bit easier to hopefully if we go back to ask questions. So let me load it one more time. I should probably get rid of all my notebook, all my pages, which I know no longer work. Dead kernel. Okay, I'm back, I believe, with a live kernel. So run all cells. And we are back with our figure. So okay, Don has expressed right an ability or a willingness to cooperate with preparing that glue code that will help X3D work better. Really, it's that X3D would accept NumPy directly. And Don, this is you're familiar with this. You're familiar with the idea of typing in Python, and the Python native types are list and tuples. And we would just, or you or we would just want to add NumPy arrays as an additional allowed typing for those large coordinate sets. So pretty straightforward. Are there any, again, what I would like to do now is open it up for people. I mean, we can go through this, and if there's any particular part of this notebook you would like to look in more depth at, maybe not so much the calculations, which are correct because the figure plots correctly, but features like, again, it is fairly straightforward to add an image to through the notebook, and my drawing here is not nearly as elegant, I think, as this I believe is a much more elegant sketch of the geometry than appears in this. So really, I have something to aim for, and of course this very neat kind of woodcut looking thing. But again, the point of this is to, in the documentation, point out, give some flavor of the geometry. And this cell is what's called a markdown cell. If you're familiar with markdown, it's the structured text that you can use in notebooks. And so in this markdown text, you can also include these mathematical symbols, such as the little angle sign. And the full markdown is fully compatible with Unicode. So in your markdown, you can have all kind of symbols available. Okay, so again, I would prefer to not so much go in the places I want to go to, but if there's any, again, further questions or hand raising, let me allow you to do that while I drink. Yeah, I will point, and I in fairness, maybe I will point out that the Jupyter, again, if you go to the jupyter.org site, there are a number of packages which support 3D visualization. So this is not the unique way to do 3D visualization. Most of the 3D visualization tools, which are sort of commonly described on that Jupyter site, are really aimed at doing equivalent of 3D graphs. So a plot with 3 axes, and you simply plot some kind of data or fit curves to it. So in that sense, or at least I see the particular role of X3D in these notebooks is kind of complementary to the idea of drawing a plot, with 3 axes and a bunch of data points. The figure I've had here really is a geometric figure rather than some plot of some kind of data. Likewise, the work that Andreas and the folks with Open Cascade did, they're not plotting data; they are plotting the real geometry of a manufactured object. So, yes, answered it, Nicholas. So Nicholas, to answer your question, Nicholas asked, X3D PY exposes the SAI to Python coders. I think in spirit, you're correct. The way I look at it is what X3D PY does is it enables you to construct the scene graph in Python code. And that might be exactly what you said, but I use different language for it. And maybe, again, for the people who are kind of familiar with Python, I can show you some of the convenience classes. I think this will bring up, yes, okay. So this is Python code, and you'll either recognize it or not. But the point is that my convenience class for sphere enables me to generate the shape of the sphere using the X3D, the class from X3D called sphere, and this is the X3D spec for how you define a sphere, which just by the radius, and then you construct the little fragment of the X3D scene graph, meaning you enclose the sphere in a transform, and you move the transform up where it needs to be using this translation field. So again, what I think of the X3D package is it lets you construct the scene graph in a very direct way, and that's the the whole power of the declarative style. And again, this is I'm not trying to circumvent the X3D specification by defining my own class called sphere. It's just for this very particular application, what I did for this figure was several times I made a sphere and I moved it up to a position. And so, again, rather than repeating that code several times in my notebook, I encapsulate it into a Python package. There may be other, as I can, a notebook is a task. There may be other tasks where a different way of presenting the sphere is the useful way. So when I define a special function called sphere, it's sort of a very task specific function or class. And I may have a very task specific definition of an index triangle set, which is pertinent to terrain models constructed from GPS readings. It's not really intended to be added to the standard. It's a task specific extension, kind of similar to what we in pure X3D might call a prototype, a sort of a one-off pattern. Again, I guess I really enjoy these discussions. I think that's the the best way to go from here. I'm available for other discussion, or if you organize, I know it may be getting to sort of later. I know it's been a long day because I believe that the first session, at least in the it was H-Anim, which was 7 hours ago. So is that right? No, 9 hours ago. So I know it's been a long day. So
well, we have a session after the we have a session also after this one that starts at
it's a long day, but it's not
7
over.
p.m.
Yes,
but
you're right.
I mean, it's not a major issue if you think you have finished now. We can
I have finished,
if someone has more questions,
yes,
comment, and things to ask. And
I say, I'll be happy to stay on.
I especially like the fact that in the end, after you created that shape, the notebook also displayed the X3D XML code. That's
you're correct. That is an important thing, which I forgot to.
You have the dynamic notebook, and then you have the static notebook. But in the end, if you just wanted to create an object, you create a parametric object, you create a parametric visualization, in the end it's just, I don't care about the calculation. I just can copy the model that I created through the notebook, and I'm ready to use it in any other web page I may need to.
I'm very glad that you reminded me of that. I did. If that point is actually in the recording, which we were unable to play. But let me just, for those who didn't catch that, I'll bring this back up. And this is not an automatic. This is not done automatically. This was a feature. I put this in as an option. Let's go down.
I see it's the
let-
result
yes,
of a call,
yes.
write XML.
Right. So I
Yeah,
mentioned
at the moment, your video is kind of pixelated, but yeah, we will try to see if it comes better. So
Okay.
for the people that already opened the notebook, is just at the end of the first notebook that was shared. So after the 3D visualization, there was the XML code. So now it's appearing also on the screen. And now it's disappearing again. But yeah, it was visible for one moment.
Yes. Just a few details. So yes, you can see that it was very simple for me to add the option of printing out the XML. And again, this is a fairly compact X3D model, so it's sort of reasonable, as you said, to simply put it into the notebook like this, and you can copy and paste it into an X3D file or a text file to save. It is also possible either on your local installation or even on this binder to save this text to a file and make it available for download. So, and then, we call this the XML encoding, which is in detail, it's a little bit different from the HTML encoding. Most notably in that you can have those self-closing nodes, such as you see in the background node. They're at the top of the screen. But yes, I'm glad you reminded me of that. Is that we do have this extra option of getting the X3D available as text for archiving or for inclusion in whatever content you're creating. And again, maybe I should also again emphasize that even though the example I showed was very simple, a few cones and spheres and planes, there's nothing sort of stripped down or this is not a light as an LITE or a miniature version of X3D. This is the X3 DOM JavaScript library. It supports, supports the most of the X3D standard, including the GLTF inlining. So it would be possible in the context of this notebook environment to import and display a GLTF file. And I probably should have included that as an example. Supplementary material.
So are there any questions or comment from the audience? Seems that is not the case.
No.
So we thank you to all the attendees, and we thank the speaker for this interesting talk. We can have a break now, and for the people interested, there's a workshop that starts at 7 p.m. So we may see you there. And thank again for everyone that participated to this this tutorial.
Okay. Here, I know Don, for some reason, asked me to stop screen sharing so we can see with everyone else. So. Hello, everybody.
If you send us the video, we will put it on the website and the WUVA channel and the YouTube channel.
Yes, I will resume. I guess I'll have to restart that download, but I will do that right now or Yes, very near future. After I get more coffee.
See you later then. Bye.
Okay, thank you. Thank you everyone for attending.
Afternoon, everybody. Is somebody on that can answer a quick question for me?
Hi, John. Can you hear me?
Hey, Anita, how you doing? Yes, I can. Anita,
Okay,
can you help me? Can you help with something real quick?
Pardon me?
Can you help me with something real quick?
Sure, sure.
Alex Viana has his presentation. He dropped it into the Dropbox on the server last night, and he's unable to access it. Do you know how to pull from Dropbox?
No, I think they will broadcast it. Let me just text them, okay? They will if it's in the Dropbox, Marco and his team will drop back. I'll just check and make sure that they have it, okay?
Yeah, everything's
about
fine. Alex is scrambling because he's concerned he can't get to his presentation.
No, I think they'll broadcast it, and then you guys the recording will be shown, and then you guys will have a Q&A session. Isn't that how you wanted it? Or he wants to present live? What does he want?
Thank you.
I'm just sending a message to the team, okay? Just give me a minute.
No problem.
He'll let me know if he has it, and it'll be broadcasted when the session starts. Is this a joint presentation, or you guys are presenting individually? John, did you send your presentation to, or did you upload it yesterday?
Hi there. Where you did send the presentation?
Alex says he sent it yesterday. Do you have it, Marco? Alex Viana? He uploaded to Dropbox yesterday. It's for this presentation, the next session. I will text him and check with him again, okay?
It's not on the Dropbox, and it's not in the email. I haven't received an email from Viana since the beginning.
So could you do me a favor? We still have a few minutes. Can you put the link up to the Dropbox in the chat box, and he can upload it now? Or they'll have to present it live.
Well, let's have him present live.
John, John, Marco just joined us. He says he does not have Alex's presentation. He doesn't see it in the Dropbox. And he just added a link to the chat, to the Dropbox.
They're going.
Luke needs presenter access.
Okay.
Luke, yeah, where is he? Is logged
Okay.
in. Luke Feast. Yeah, okay.
All right, Anit.
Okay, mic check. Does this work?
Has been promoted to panelist. Yes.
Yes. Yes, Luke, we can hear you.
Yes,
Perfect,
I did
thank
it,
you.
Marco.
Hey, I did upload the presentation to the Dropbox this morning, so I got a confirmation it was uploaded successfully. I guess if it's not seen at this point, I'm not sure we're going to get it up.
This morning. The title of the, because this is what I have. What I have in my Web3D.
What is the title, Luke?
I haven't uploaded mine. Alex's, I'm not sure. It doesn't look like it's on there.
Huh, yeah. It was uploaded this morning, but it looks like it's not showing up.
The web version of Web3D. No, I see the same.
I uploaded this morning, Marco, and it's there. So I'm just curious what's happening. The upload worked for me this morning. Luke, would you be able to present live?
As far as I know, here I'll try and push some slides right now.
Okay, I'm in process of uploading again to the Dropbox.
Okay, perfect. Let's try that.
Can y'all
That's always
see my screen?
best to have slides on the server, best for group bandwidth rather than single point of failure. Marco's doing a super job. Over.
So John, if Alex can also upload right now, it would be helpful. We still have a few minutes.
Yeah.
Yep, it's uploading right now to
The Dropbox, okay.
Yep.
What about you, John?
Yeah, that's fine. Alex is trying to do so. He's working with Luke. They're together.
So is
I am
Alex,
not, I am not presenting Anita. There's only two presentations. Luke
okay.
first, it's Alex second, and they're going to be only talking briefly about it. But the intent was to use their presentation to kind of facilitate.
So Alex still has time to upload it if he wants to, or he can present it live.
Did you try? Are you razzed in, or are you? You're not on full screen. You're not. So I just uploaded my slides. They should be in the Dropbox now.
Yes, these are. I see slide and.
So did you want me to share my screen and present that way, or I'm not real good at Zoom functionality.
Yeah, these are slide. I mean, I can share my screen and you just tell me where to go on, or you can do it live. I see no problem on your side, but every time that John Willett try to speak, I read an error message that his bandwidth is very low. So I don't know if he will be able to present. But yeah, I have the slides here. If you prefer that I run the presentation and you just talk over it, if you prefer.
Sure, that's fine with me.
Okay. So let's try.
You may want to go to the slideshow mode.
Work. Can you?
Yeah. Okay. Got it.
Can you all see the slides?
Yes. Yes.
I'm good.
Okay. Perfect. So when the time comes, I
see different colors.
So you just appeared here, and if someone else need to upload something, we are here waiting.
John, is Alex uploading?
He is. He's trying to. He's got videos embedded in his. So it might be a file
so it may
size
take
issue.
longer.
Yeah, I don't know. Is there a file constraint? It's 179 megabytes. I don't know. Is there a constraint on the file size?
I don't think so.
No,
Is there
no.
one?
No, because for example, the video that Don sent just at the beginning of the afternoon was 325 megabytes.
Okay,
There
great.
are other files that are more or less the same size.
Well, we're about
almost 1
5.
gigabyte. This one.
Wow, wow. We're getting close.
Pretty
We got
large
maybe
video. I don't know
5 minutes
why is
down.
this big.
Really pretty good though.
400, 500 megabytes. So 1 gigabyte and 39. That's the record. That gets the.
Luke, did you update your video recording too, or just your slide sets yesterday?
I don't have any videos in mind.
Okay.
I'm not that high speed.
Done.
Okay, looks like looks like it's uploading right now. Alex is. It took a while to get it like pre-uploaded, and now it's uploading, but it's at 30% and counting. So it's moving quick.
The session is scheduled for 7, so plenty of time.
It says it's finished. It says it's finished uploading.
Okay, I'll check. It's arriving, and it's here. Okay, should be on my screen so you see if everything is okay. Screen share. You see everything? It's a pretty large model. Let's see the video. Yep, the video seems working. Can you see it? Guys?
Yes.
Okay. Should I also share the sound? There's a sound on this video, but it's basically just buzzing. Okay, John was kicked out. I'm trying to promote it back as a member.
I'm not sure if John is going to be speaking. He may not be presenting. Luke, is John planning to present? I mean, trying to just participate in the.
I'll follow your lead, guys. I can chime in when you want, or if I see something cool that deserves extra clapping, then I'm at your service.
Anita, you asked a couple of days ago if we would keep the registration open, and the answer is that people are registering even now. I mean, we have three more registration in the last hour.
Marco, that's because I was getting text messages. They were going and watching the conference live, which is on the homepage. And I said, no, you have to register to participate in the conversation and discussion. So
Oh, well, I'm not that strict. I mean, if they just want to watch through YouTube, for me, it's fine. I mean, we will get statistics in any case. Yes, I'm trying to promote as member, but I don't get any response.
It just
Promote as member.
That thing's on your freaking inbox?
I think he dropped off. He's not on the call on the Zoom. He's not in the
I just got
webinar.
off the phone with John, so he should be coming back on.
Yeah, he's
right
back.
now.
He's back. He's back now.
Okay.
You can elevate him. He's back in.
Okay, this time it worked. Okay, he's on the panelist.
Thank you all. I'm sorry about all the challenges here. It's just been one darn thing after another. All right, I am really connected, so appreciate that.
Yes, now I'm not getting the error that said that you had the low bandwidth. So now it seems everything okay.
Yeah, thank you. Yeah, I don't know, Marco, what ended up happening, but fortunately, yeah, I had an interesting little flux with my connectivity here, and thankfully it seems to have resolved itself.
John, if it's, hey, John.
I am, yeah.
If it's possible to secure the background fan, then I think your video bandwidth will be better. Your image will look better instead of competing with the
Well,
blades.
how about this? How about if I just move? Is that better?
Oh, man. I love motion in 3D. You know that.
I figured you did. So I figured we'd start this session off on the right
Okay, the session was scheduled for 7 p.m. We have all the panelists, I believe. We have a few spectators. And so if you think it's the case, we may begin. What do you say?
Thank you, Mark. I really do. Well, good afternoon, everyone. I appreciate you taking time out.
Your connection is not really stable, but yeah, we can go through it. So,
okay.
So welcome everyone to this final session for today. It's a workshop. It's a workshop improving 3D site characterization, driving innovation that improves 3D rendering of natural and man-made environments. So who will be presenting first?
Okay, Marco. This is John, and I want to welcome everybody here this afternoon to this meeting. Like everyone on this call, I'm hoping everybody's enjoyed the previous sessions and the ability to have an opportunity to learn a lot about the innovations and advancements that are occurring in this Web3 community. Inherently, we are making a lot of great strides in areas of research, development, and publishing. And I've been really impressed with the diversity of topics that have been discussed up till now, as well as all the concerted efforts across the community to enhance and improve the way we're visualizing different types of models and features in the web. So with that said, one of the challenges inherently we're dealing with is that we find ourselves in a world right now where inherently we're able to start collecting data and three-dimensional data in a variety of ways that we probably had thought about just a few years ago. It's amazing in my mind right now. I can take my iPhone, my Apple, and basically right now go out and actually collect LiDAR data of image. You think about some of the other broader applications and discussions earlier in the web at this meeting with regards to metaverse and how advancements in VR and AR capabilities are taking place. Advancements in photogrammetry, advancements in bathymetry, sonar data. It's just, we're finding ways to collect man-made and natural features in a way that we haven't done in generations. And while it's exciting, it inherently has some of the challenges. And so this workshop has kind of evolved from the time it was initially submitted, because as we began discussing with different users of X3D as well as other applications, it became apparent that we need to be thinking about how an X3D domain or other domains are being used by our clients or being used by the community as a whole, and being promoted in a way that inherently is getting the maximum value on the web, and it's truly extensible. So from this standpoint, our interest here was to begin basically using a couple of users as a mechanism to kind of facilitate discussion. Because what we're ending up dealing with is, while normally a want here has been to pull data together of a similar type and to be able to use that data in a way to create models, inherently we're finding ourselves using data sets from different sources and several data formats. Examples are CAD, Revit, GIS. In that case, one has to manage merging this diverse material into a uniform representation of the environment. And X3D has shown that it can work there, but we also have realized that we do have some challenges with the ability to easily convert to X3D. We have challenges working seamlessly with other programs like Builder, like MeshLab, like a variety of other platforms. And rather than spend a lot of time just developing and just laying out the different challenges that users are having, I wanted this workshop to kind of focus on some applied guidance and kind of use case scenarios to illustrate some of the challenges that different individuals are having. In this case, we're using two individuals that are very familiar to our community. One is a colleague of ours, Luke Feist from Swift River Environmental. Swift River is a small 8A small business that is providing a variety of remote sensing and 3D modeling applications to a variety of clients. And another one is Alex, who's actually listed as a co-presenter for this workshop. Now Alex is intended to present some of the cases, at least one in particular case, of some of the challenges pulling together a variety of different data sets at a very large scale and trying to make that seem extensible to the environment. And my hope here is by showing these use cases, it will facilitate towards the end of our workshop here some discussions about where we as a community need to find ways to better support individuals like this and help find ways to overcome some of the challenges that they're facing. With that said, Luke, do you mind if I let you share your screen with the team and let you kind of dive in? Luke, are you there?
Sure. Did you want to push the slides
here?
there from the other side? Yep. Testing. Comm check.
Hello.
Testing.
Yes, I'm doing. Yep.
Okay. John, can you hear me?
Just tell me when to go on.
That's an interesting way to put it. So it says.
Yeah, look, I can hear you.
I haven't seen it pop up yet. So. Oh, there we go.
Yes, I can.
Now I'm getting the internet unstable message. Okay, here we go. All right, so the background of my presentation is going to focus on the OODA loop. So there's the title slide.
All right.
Go ahead and go next slide, please. Is my okay? I'm good with this. Next slide, if you can, please.
This is the first slide. Yeah.
Hello, testing.
Okay.
Okay, there we go. Thank you. All right, so for those of you who are not familiar with the concept of the OODA loop, thanks, Don. Oh, I'm sorry.
Yeah, look, it's you're there.
Okay. I feel like I may have like a very substantial lag through this system here, so apologies. Perfect. Okay, so here's the OODA loop, and this was created, in the Air Force to support fighter jet dogfights, right? And the basic concept is, okay, observe, orient, decide, and act. And the faster you can complete that loop to where you act and then observe the results of your actions, reorient to the new observations, decide what to do next, and act again, the faster and the tighter you can create that OODA loop, the better off you are going to be, the more informed you're going to be, the better decisions you're going to make, and the more effective your actions will be. And, inside the context of the fighter pilots, the faster they could act, the more disconnected they could make their opponents or their adversaries from reality. I think, some folks would argue, hey, this is kind of outdated. I disagree. I think the OODA loop is more relevant than ever in the 21st century. A lot of, if not all of my projects right now are connected to the US Department of Defense, who is struggling mightily with a innovation challenge, I guess I will say. So why is that? I would argue it's because we have allowed, the Department of Defense has allowed themselves to be out OODA looped, right? The world is moving faster than the department can observe and orient to. So before they get to a decision point, the world changes, and then they have to re-observe, reorient, and then figure out what they're going to do. And by the time that happens, the world changes again, right? And in the context of this brief, we're going to look at primarily some base laydown and some installation resilience issues in context of climate change and sea level rise. So next slide, please. Looking for slide 3, I think.
Okay.
Thank you. Okay, so this is a little bit of a visual representation of the OODA loop, and you can see there. And so, I've already talked about that first bullet a little bit. Hey, the faster we can do this stuff, the more effective we're going to be. And in order to do it right, we need to leverage the things that we've already got, right? So if we need to develop a new tool, well, that takes its own amount of time. But if we already have these large existing databases, these systems, tools, everything, like how do we maximize the efficiency and the effect of those tools in a fast and consistent manner? And the second bullet there really talks about, hey, as we move into the 21st century, a lot of folks did this 20 years ago, but some of us are still catching up. The people who win are going to be the folks who can aggregate and synthesize these data sets and really put the right information together at the right time, understand what all that information means, right? When we say orient, that really means understand, right? How does what I see relate to what is real, right? Like in the jet pilot concept, hey, the adversary plane is flying south. Well, so what, right? Flying south doesn't mean anything until I put the orientation that, hey, I'm flying south. Okay, am I in front of or behind them? Or if I'm flying north, do I need to turn around? So, okay, we're going to orient to that data, then make decisions, act, and re-execute our OODA loop. So, as we said, the folks who can synthesize, aggregate this data, figure out what the information is that can be brought from that data. They're the folks who are going to win and get out ahead of their adversaries. So next slide, please. Okay, so how does this all apply to anything that we're doing in the world of X3D? So what we've been doing here is we've partnered with our government folks, our primarily NAVFAC, the Naval Facilities Engineering Command, and we've developed some stuff along with some partners that are on this conference as well, and tried to develop new tactics, techniques, and procedures, TTPs. Sorry, I'm distracted by the chat. The new TTPs to basically move this faster, right? Like, hey, we know it's big and it's slow to go out and collect these data sets, to go out and digitize the real world in order to be able to make real world decisions in a digital environment. So, hey, how do we go about doing that faster? How do we go about making that data more reliable, right? Do I know that, hey, if I scan this building and it says it's 10 meters tall, how do I know that it's not 10.2 meters tall or 11? Right? How do I trust that data that we're getting? And then how do I use that data to really make decisions? How do I present that data in a way that your lay user can understand and appreciate? And then how do you put it in decision makers' hands to inform the decisions that they really need to make in order to affect the changes that the departments and the end users actually need? Make sure I'm still on track here. So yeah, let's go next slide. Okay, so what's getting in the way here? And as I'll point out here in the next couple of slides, there's a handful of barriers to what I would call successful integration of the data into a usable end product. And again, I'm focused at the lay user level, not your power users, not your developers. How does a salty old Navy captain make a decision in the 21st century when they're used to typing in all capital letters because it makes the file size smaller and they can send it to a submarine? So hey, in a world of big data, how do I get these folks who are very averse to big data to make decisions based on it? So one of the biggest ones, and John already talked about this, is the disparate sources, right? Like, where is this data originated at? Is it LiDAR? Is it photogrammetry? Is it Revit or any 3D CAD models? Is it older than that? Are there navigational charts that we're using? Are there topographic maps? Are there hydrology? Is there bathymetry? The lack of clear insights. Okay, so we put it all together. What's it mean? Like when 1 + 1, does it always equal 2 in this environment? I would say not always. Scalability has been a large challenge as we say, okay, well, I can do one facility, I can do one block, I can do 1 acre, I can do a base. Can I do a state? Can I do the whole planet? At what point does this become too much? And where is that sweet spot as far as, okay, this is what the technology can support. This is what keeps a model usable. How do we scale the size, the data, the quality of these models that we use such that they are the most effective? And then, the complexity involved in predictability. This is, when you actually get down into the decision-making process, again, this is a 1 + 1, what's it equal type thing. If we're talking shore resilience, is it as easy as making a taller berm or a better seawall? Or, is the flooding that we may experience caused more by rain than the sea level rise, and now we've just trapped the rain even more? So how do we make these decisions in a complex and changing environment? Next slide, please. Okay, so I'm going to go through just a quick kind of case study that we've done. And I'm not going to say it out loud, but if you have seen a map or been to a vacation spot, you may recognize some of the pictures I use. So what are we doing? What we've done is we have created a visualization tool to basically allow folks to collaborate real time and live and work inside of this modeled, almost a virtual twin. And I think when Alex follows me up here, he will show you a much better virtual twin where we can do things like change the environment to show what we're looking at. And I'll show you here in a couple slides, but hey, if we're looking at sea level rise, well, okay, let's model the environment. Let's show where the sea level's at now, and then let's raise the sea level and see what happens. And what we get from that is it allows us to make some decisions about where our risks are. What do we lose from flooding? What gets, what are the impacts of nature changing? And then what are the impacts of the mitigation strategies that we choose to execute? So, I think it's only the early innings of this technology, obviously, as we get further and further along into the 5G and WEB3D and Internet of Things, right? As the world goes meta, so to speak. We're in early innings of this, and I think it's all on the same path that it's all going to improve. That, I guess it's a apt analogy here that a rising tide will raise all boats in this matter. There you go. That's absolutely true, William. Next slide, please. No, I'll stop throwing words at you, I think. Okay. So here we're looking at this case study here being just a large scale waterfront infrastructure, right? And as you can see, there's a whole lot of shoreline right there. There's a whole lot of very key infrastructure and a whole lot of stuff that A, was really expensive to build, B, will be next to impossible to replace if it's lost. So this needs to be protected and is of immense strategic importance. So, hey, losing this is a non-starter, and degrading its capability is almost just as bad. So how do we maintain the capabilities of this environment, of this facility, of all the infrastructure associated with it, when we know, right, that the sea levels are going to rise and it's going to have an impact here? And then not only that, like, hey, if we try and attack that problem via a 3D virtual environment or a digital twin, what else can we get from that? Can we get some other benefits from that? And then, so I talked about some of the challenges we've had. So you can see just by looking at, I'll say the picture on the bottom right there, where, okay, what data sets will we have here, right? Obviously, we've got some overhead imagery. We've got terrain maps. We've got some navigational charts with bathymetry. And you start overlaying some of this data. And what's it tell you? It's really hard to go from all these individual sources of data into an informed decision, right? If I know where the floods, right? The watershed's going to funnel water in this area, right? This area is lower than that area. Okay, so I can get some general ideas. But it doesn't really tell me that I'm going to lose the building right there on the end of the pier. Right, I really have to guess at that. So if we move into a better model, next slide, please. And here I'll talk about a little bit of the X3D stuff that we're using. So we've chosen to go through and create this virtual environment in the X3D, built on X3D, right? And largely because of the reasons associated here. It's extensible, it's cheap, royalty free. Like we're not paying the Esris of the world to maintain all this stuff for us, and we can do a whole lot with it. Next slide, please. And so this is what we've called it. It's Spiders 3D. It's specialized infrastructure data repository. Alex will go into a little bit more on this. But inside of this, we've built a whole bunch of models of real world stuff like weapons platforms, facilities, support equipment, forklifts, trucks. We've got, sailors that you can put into scenes. And it allows us to do visualization and collaboration in real time, right? We can create these storyboards and show and demonstrate alternatives. Say, okay, if this, then that. And it allows us to iterate, right? And we can kind of run OODA loops in a virtual environment, right? Like we can reach 100 years into the future or 100 days or 100 minutes into the future and see what happens. And oh, by the way, due to the things that we get out of the X3D platform, I can put a bunch of users in this, and they can use really low-end computers. Like the average Department of Defense computer is not very powerful. They can get on through a web browser, collaborate in a scene with folks across the planet, and they can all speak the same language and see the same things at the same scene, which is incredibly powerful for the types of uses. Next slide, please. For the types of stuff that we're talking about. Okay, so here's just kind of a little bit of a visual representation of what I just said. So we're taking these 3D models, right, and these all coming from different acquisition strategies, I guess. We've got designs from the manufacturers of some of these weapons platforms, whether that's an aircraft, a submarine, a surface vessel, or a facility, and we can import those in and convert them to X3D models. And so John talked a little bit about this in his lead-in is, hey, if that process was easier, that would make this whole thing a whole lot easier. Right now, that's a bit of our crunch right now is transferring that data, right? Converting that data from whatever native format it is into X3D. Once it's in X3D, we upload it to our catalog, and now we can pretty much drag and drop it into our scenes. So once it's converted into X3D, it becomes very powerful for us. But getting it to that stage so far has been a very large chunk of the work. And then now once we've got it, we can render these scenes and manipulate these scenes and use them as a very powerful collaborative tool. And then we can keep iterating. So next slide, please. Pretty sure. Next slide. You can see how complicated this gets when you start talking about, hey, how to orient yourself to that scene. So, okay, we digitized it. We created this fairly detailed virtual environment here that, they're missing quite a few ships, but we've got those ships in the inventory of the system, and we can put whatever type of ship you want in this scene. If you want to pull aircraft carriers next to the pier, if you want to put tugboats, if you want to put rubber raiding craft, we can drop them all into this scene and show you what it's going to look like. And from that, you can orient yourself to the scene a little bit and say, hey, I hadn't thought of this. How do we get 5,000 sailors on and off the prow of this aircraft carrier? So there's different things you can walk through. And I talked a little bit about, hey, what are the second layer benefits of a system like this? We created this to show you the image on the right. Hey, if the sea level comes up 2 feet, what's it look like? Well, hey, that whole pier there on the left side of the picture is flooded, right? There's water everywhere. That's no bueno. And another benefit that we've gained out of this is the ability to use, hey, this virtual environment that we've created. If the systems acquisition folks are trying to develop these new weapons platforms, right? Whether it's a new aircraft carrier or a new submarine or new unmanned systems, they have these very difficult challenges of where are they going to put this stuff, right? You see how busy, go back one slide, please. Right, hey, I'm the Navy, I'm going to spend $1 billion on a new ship. Where are they going to put it? And they struggle very mightily with those sorts of basing decisions on where can I have the capacity to store this stuff? You know, what are the capabilities of these piers and these wharfs and the harbor itself? Can they do what they think they want to do? And in the past, it was really difficult for them to make those decisions. But what we're finding right now, go forward 2 slides, please, is that since we built these models in a couple different places, they become very powerful for the use of planning. Where are these acquisition folks going to put stuff? And then this is back to the resilience. Okay, so we can play with the sea level rise, right? At 4 meters, bad things really happen, right? That's what, 12, 13 feet of water. Like that's going to be a problem. One more slide. And due to some of these models, right, we've got the detailed insides, like we can see actually where the water is going to be inside some of these buildings. Hey, what do you lose? What do we need to protect? You know, can we afford to lose the inside of this, that bottom left picture, right? If that's full of sensitive equipment, hard to replace equipment, well, that's a bad day, right? If it's full of trucks that can be moved easily, if it starts raining or if the seas are coming up, okay, like we can move those. So they can make those sorts of risk decisions. And I think that's my last slide. Push one more, please. Yep. Okay. So, oh, okay. That's weird. All right. So there's the findings, I guess, from some of our work to date. But really, what I'll try and leave the group here with is how can we make this onboarding process of this data, the conversion, and then the manipulation of the data once it's inside of the X3D environment. How can we make that easier? How can we make that you know, more usable by your average person who's not going to be in there every day, who needs to go in, visualize something, manipulate that environment to whatever need they have, make a decision, and then leave, right? And then come back maybe the next day or the next year, and use that tool to their benefit. So how can we make that easier? You know, at the developer level, anything is possible, right? But at the level of the folks who have never used these tools before, how can I make that better for them? You know, I'm sure many folks in this event have used virtual reality or augmented reality stuff before, but holy cow, when that stuff works, it is really powerful. So if we can get something like these models into a virtual environment or a representative, yeah, there are no human, yeah, there you go. So yeah, how can we make this more powerful? And I think AR, VR is going to be a big one, and Alex will show you some stuff here shortly. But that's where I'll leave it, is, hey, how do we make this better? And I don't necessarily think it's better technology at this point. It's going to be better usability of the technology. And I'll kick it back to you on that, John. If there's any questions, I suppose we can look at those quick.
Okay, so thank you, Luke. I really do appreciate you rolling things out. Alex, if you don't mind, I just need you to just do a brief introduction of your challenges, and if you mind showing your slides, I'd appreciate it.
So the other set of slides.
Yes, please.
Yep.
Alex and I are sitting next to each other, so you will see some sorcery and just like that.
All right, Alex, make your first slides up.
Okay, awesome. Thank you. So build on Luke's presentation. We're going to get another use case in terms of looking at how we use X3D to, again, integrate lots of disparate data, be able to contextualize and be able to provide a bit more of a shared insight. What we're going to show here is, the challenges we're seeing is, again, how do we now take that X3 data? How do we enable presentation, enable users to interact with the data? So not so much the back end, but maybe just the front end of how folks experience the X3D and some of the challenge we have that kind of we're living with in the military in terms of trying to implement that capability. Certainly we see X3D as a great, affordable, sustainable technology. So what hopefully we'll show you is that those capabilities being delivered, and talk a little about some of the challenges we go forward to again provide that interactivity. Next slide, please. Just a quick what's driving us here. Obviously, there's probably similar drivers, and not just the military, but in the business world. We just need to be able to move faster, be agile, be able to communicate a much faster, more robust construct than we have in the past. With the emergence of digital engineering, data strategies, using virtual environments really is kind of a key pillar of how we can deliver that data to consume through visual communications, and be able to leverage investments that we have in quite a bit of data and unlock and be able to maximize the value. Next slide, please. Common themes. I think Luke touched on these things. Is again, OODA loop. Well, that is trying to kind of. So it's a one voice. How do we do this collectively? We've got lots of investments in different tools and data. We really need to take advantage and maximize those capabilities to the extent we can to create a common operating picture to really inform a lot of diverse decisions across planning, engineering, and what we'll show you is, Navy and NAVFAC, we have working with our industry and the Web3 consortium, a lot of partners develop a capability that begins to show the power of the technology and start allowing us to really exercise the OODA loop. Next slide, please. All right. So yeah, I think probably this slide is maybe I'll say preaching to the choir a bit. A lot of goodness with the technology that we've been experiencing with Web3D. The really one of the key capabilities that we're hoping to continue to leverage is the real-time network communication aspect. As COVID has really forced societies to kind of be dispersed, and the ability to really kind of engage face-to-face, have those in-person discussions and meetings getting a lot harder. So connecting real-time across time and distance so that we can learn fast and overcome those challenges of time and distance. Really, we're pretty excited about the potential we have at hand. And the fact that Web3D is a well-established technology, very stable, really is technology that can permeate across all aspects of our business practices and use cases. Next slide, please. So we're going to just kind of step through kind of a specific project exemplar just to kind of show really the kind of the scope and the breadth and the depth of all the different data sets that we are trying to integrate and distill into X3D to develop these web-enabled virtual environments. As you can see, we're starting with a pretty large size, over 2 terabytes of data of again, there's very disparate data sets. Lots of different formats, different fidelities, different capture methods. So this is a good example of how we begin to take large dispersed data sets and start to really optimize down into a common X3 format. Next slide, please. So for this project, just here are quite a number of data, I'll say metrics, give you a sense of the scale that we are working with. Just, I guess I won't belay this slide too much. There's just a lot going on in terms of just different data sets, the amount of area that we're trying to visualize, the disparate types of infrastructure. We're going to show in this example the ability to, again, create an environment that we can now present different alternatives of future sea level rise. Really, I think the takeaway here is at the bottom is the accuracy. This is really getting towards a geometrical, geospatially accurate digital twin of a very large installation that will enable us to do a lot of collaboration with. And again, that's with, that's aerial, that's undersea, terrestrial. So quite a bit of information in a very accurate rendition here. Next slide, please. Again, here's just a list of the different sources of data we're working with. Again, photogrammetry, LiDAR, sonar, CAD-based models. As you saw the previous slides, kind of the native data set starting at over 2 terabytes. As we begin to mesh and optimize the data sets, we're now, vastly, major magnitudes of reduction in some of the file render size, and again the need to reduce the file data sizes. We're, as Luke indicated, we're working with very low end computers, very basic hardware capabilities, and so the ability to take this massive data sets and be able to run on these base computers with very limited constricted network bandwidth really is a key to the success of our efforts here. Next slide, please. Just to kind of highlight the transformations of the data sources. What are we transforming in terms of the geospatial qualities and really the end products, right? So the end product is, again, a web-based virtual environment that will have some level of user interactivity, allow users to interact with different data sets overlaid onto the virtual environment to provide that insight and understanding of the complexities of the installation. Next slide, please. Okay, so I'm just going to show us a short video here of the installation. As you can see, there's toggling, which is bringing forth new data sets. We have vegetation, we've got infrastructure. So again, the ability to toggle data on and off to provide unique presentation perspectives, be able to really allow users to focus on those key elements that need to be discussed. This scene is got, again, as we indicated, quite a number of different features. As you can see, the level of fidelity in terms of the infrastructure down to individual components. We've got the ability to present users with an environment that has a range of elevations from minus 17 meters to 32 meters. So again, the Z value that can be shown, that's hard typically with a lot of different tools. We're able to really present that well and allow users to have a very good confidence in what they're seeing. All right, next slide. I have to hit the next slide again. There we go. And as I think Luke and John indicated also, the ability to really kind of take the data to the next level, immerse users in the data, provide a much more visual and haptic experience to understand the complexities of when we provide alternatives to do different infrastructure elements. Now we can put folks in a much better viewpoint, immerse them in a perspective that provides the insights that we typically don't get in traditional 2D projections or even static 3D projections. Again, the ability to leverage X3D and its simplicity in terms of leveraging HTML and JavaScript, be able to deliver this just through a basic web browser is fairly powerful. And then, now bringing in other data sets so that we can start to evolve to a construct where we can integrate on a kind of a more efficient iterative basis, whether it's new hydrological models, weather, buoy, data feeds, bring in different models of weapon systems and buildings infrastructure. So this will be a foundation that allows to really kind of start interchanging these data sets on an easier basis and present at large scale. Next slide, please. So here's another short video. We have Dr. Paulus is kind enough to render a 3D virtual environment in Miriam there at Virginia Tech. And just to provide the ability that we're experiencing with the technology to bring stakeholders into an immersive environment they've never had before. And the ability to get to have those shared insights, reach consensus on decisions. We see this type of immersive capability to meet the future acceleration of users, right? So we can start having multiple visionaries or multiple caves being able to render across the time and distance.
Alex, we're having a little bit of issue with your audio.
Okay, I'm sorry, there's audio and video, yeah.
Video's fine, audio is where we've lost you.
Those of you want to just go to the next slide. Next slide, please. Okay, and now just a quick interface. So this is kind of, as we've been talking leading up to, is I think we really understood well how to leverage X3D to instill a lot of these data sets. Show you this is a very basic example of an interface. And this is probably the challenge that we're seeking to help us is how do we really, what are the tools, how do we quickly enable users to develop interfaces that can support a wide variety of data consumption. So as you can see here, we simply have some toggles so that we can present different layers of data. So again, this is an opportunity for us to feedback from the community to see if there's how can we do this on a more easy basis to create these interfaces to render and publish the data.
Okay, Alex.
Hey, Alex.
Yeah, we're go.
Go ahead, John.
we're gonna probably need to just ask you to stop there. If you want to just show your next slide, because I think it's a good one to end on. Yeah. So yeah, you're just coming us so Gramble, we just can't hear you. So we're going to end there. I want to thank you and Luke for it. Everybody, obviously, due to technical issues and a little delay, we ate up a little bit more time than we anticipated with our session today. I think the thing that I want to allow you all the opportunity to do is to kind of understand some of the use cases from an applied standpoint that those out there working with X3D are inherently having. The chat exchange has really brought up some really interesting questions. I do appreciate people putting a couple of questions into chat, because these are the intent here with this workshop was not necessarily a want to necessarily generate solutions. It was not necessarily a want to emphasize patches or different approaches that we can end up taking. Inherently, the want of this workshop was to create a thought exercise. A want to inherently create a mechanism that we began to think about to go a little bit further than we have with regards to go beyond the aspect of the code to understand how do we find ways that we are ensuring that the domain has the best value proposition possible, and that the domain is not just having a value proposition within the X3D community, but we're having an opportunity to realize how the domain is being utilized and potentially has value proposition to our peers in places like OGC, et cetera. Inherently, as we're dealing with this want to integrate disparate data set from a variety of different locations, and that we're looking at them at fine scales and broad scales, and we're looking at human dimension elements, and we're looking at cultural resource elements, and we're looking at issues with regards to challenges geospatially. I think the thing that we're looking at is that inherently within our community, within the X3D consortium, that we've got to find ways to work across even our own working groups to find ways that we're finding ways to be a lot more applied in the way that we're thinking in an applied mindset for how the domain is going to bring greatest value to the community as a whole. So inherently, with what limited time we have left, which is about 5 minutes, I appreciate people throwing comments into the chat. If anybody has any other comments or any questions that they want to throw out to the team as a whole, or you want to have further engagement, please feel free. This is a good time to just take 5 minutes out and kind of talk about things. And Don, it looks like looking at your video, you're biting at the bit. So please feel free to go ahead and jump in here.
Well, let me just take the baton from you, John, and say that this exemplar, I hope nobody, John, I think it's your video that's showing right now. Is that correct?
John,
maybe we can show both. I hope it's coming across. This exemplar is, it's kind of, I put something in the chat. It's kind of like an industrial use case, but more general, more public. Here we have public works, we have land and sea, we have, there are coastlines all around the world with cities and capabilities. And besides business as usual, we're wondering, well, what does climate change do? How do we respond to that? What places are most vulnerable? How do we fix that? New York City got religion over a decade ago and strengthened Lower Manhattan because they were flooding out. They were shorting out Manhattan. Gee, there's an imperative. I think that it's really cool. It's not just a demo, but I saw you guys in action in the past. how you didn't have to do the demo. You just gave it to people, and then they started saying, well, look at this, what about that? And maybe we should. So I'm really jazzed by what you're showing, not just for the stellar 3D of Annapolis, but for the collaboration possibilities. And I think that's something nobody else can do right now. Over.
And Don, I think you've made a good point. I don't think that, the value proposition, as you point out, is not just in the fact that from a generalization that we're focusing on a topic like coastal resilience. The issue here in my mind was inherently by pushing these generalities up was to begin to thinking about all the different ways we're using X3D and how X3D has a broader proposition. I mean, inherently, the reason why we're getting traction in this community right now is inherently because it is open source, non-proprietary. It ends up becoming a bridge that inherently right now the community is looking for. It needs this type of tool and extensibility to be able to really be able to get the most value out of the data that it has. And that's what we're talking about here. How do we maximize data? And how do we integrate disparate data from numerous different sources? And from our standpoint, it's one of those things where we can do that and we can show greater value proposition if we work on thinking about how do we improve our converters and how do we end up allowing people to move easily from different softwares to different softwares and how X3D can help improve that. It gets into issues about ways of us basically ensuring that as understanding that there is so much advancement in the community that we within the Web3D consortium cannot end up doing this by ourselves. And we ourselves need to work more collaboratively internally and work more collaboratively with different other partners and stakeholders that have inherently an interest in 3D on the web. These are things that I think we need to find ways that we're thinking about. So as I say, the intent here wasn't necessarily to wow anybody. It wasn't necessarily to focus on coastal resilience. It was to try to get us to begin thinking about where we as a community need to begin thinking about understanding things are changing and we need to make sure that the domain is evolving with those changes. Okay?
Yeah, and let the record show New York City was not able to do what you just said until the water started flooding over the low seawall and filling up the subways and shorting out the electrical junctions. And so I think you're posing something of very broad value, public value, and very important interest. Thanks.
All right. Well, thank you all. It's the hour's come and gone. I'm hoping everybody, if nothing else, as they say, our want here was to create just a thought exercise and let us all begin kind of thinking about how we want to see things proceed. I want to wish everybody a wonderful afternoon. I want to thank Marco and everybody for an amazing job of keeping things running and on time and on schedule and keeping things organized. We really appreciate it. And inherently, we're looking forward to the next few days and to obviously learn and talk about other applications and to dive further into the research and development and publishing. And I look forward to participating in those discussions. But I'm hoping that this thought exercise early in the process will help kind of formulate some of those discussions going down the road. So everybody have a wonderful day. I'm glad to see we had the opportunity in the second day and wish you all the best. Thank you all.
Thanks, everybody. Appreciate it.
Thanks.
So thank you everyone that participated in this session. If well, the discussion may go on the WUA channel, and thank you all that attended today, and see you tomorrow at tomorrow morning and at 9. Thank you very much, and have a nice evening or whatever time it is at your place.
There will be an evening before tomorrow.